Well, okay. Well, then tell you what. I'm in here and it says I'm live, so I'm not sure why that's happening.
I don't have
PT says she doesn't see it either.
Well, it says I'm live. What's going on? Oh. Well. But they can't hear us either, huh? Is that right? They can hear us.
Well,
Can they hear
and
us? That's
now
the
it's
question.
working for me. Okay.
Of course, that's Murphy's Law. Now it's on. Izabela says it started for her.
I wonder what the delay is. I don't have any delays on.
Actually, there was a delay when we started earlier before we started streaming for me.
Okay.
So maybe there's...
But it's working now.
Arizona air. I don't know.
Oh, no, because Izabela's in Sofia, Bulgaria. So, Well, anyway, it looks like we're all live now. I don't know what the delay is, but I suspect that it's going to still be playing from the beginning when you watch it back. Anyway, for whatever you missed, I was saying this is the Pleiades right here. And for those that are here that haven't been here before, okay, I wanted to share with you what we're looking at here, okay, and over here, okay, this is our camera control section, and we have a 15-second exposure I'm about to start, and we have our sensitivity at 350 for the sensor, and this is the telescope control right here, the telescope control palette. There's the telescope right there in the building with the roof off. And this is a peek into the telescope's computer. All right, that said now, what we're going to do is I'm going to come back in here and I'm going to live stack this so that when it comes up, we're going to be able to stack our images and see a beautiful rendering of these images. And first thing to do is to get off of our hypered mode where I actually had the camera at extreme sensitivity. All right, so now that's coming off, and there is our image, and I'm going to add a few things. I'm going to add some enhancement to this. I'm going to turn on some sharpening so you're going to see it gets a little bit sharper here momentarily. Okay, there we go. Now we'll be able to see a lot more detail in some things that we look at, like nebulae and stuff. I want to say hello to Daisy and Zoe Amethyst and PG. Hello there, Petita. How are you? And we have Michael Klagus, who's here, who's also doing some imaging tonight. He's imaging the... what he told me. He imaged imaging the Y cluster and the Flaming Star Nebula. Up in Auriga area, and that's really going to be pretty too. Donald Kunzer is here. How you doing, Donald? Izabela, of course, from Sofia, Bulgaria. Nice to see you, Izabela. And for now, that'll be it. We'll see who else is coming in that I missed. Anahata77, Bonnie is here. Hi, Bonnie. All right, so we are sitting here now watching the Pleiades take shape, and as I've said before, we're stacking these images, okay? So that means that we are taking an image, aligning it, and stacking the next one on top of it. We're creating an image stack. The more images with the proper data that you stack, the less you see of the noise in between all the data. What's the noise in between? The dark of space. If there's nothing there, we don't want it to actually show as anything noisy or problematic, and sometimes it does. But with this exposure, you can see the beautiful blue clouds. The stars have these purple halos. That's an artifact of the system, but I get rid of that in post-processing. Hello, Charlotte. And so that's something that I will do.
Mark, I don't mean to be a downer. Your sound is starting to break up now.
Well, I don't. Last time we talked about that, if I recall, it's only happening for you. I don't think anyone else is hearing a problem with my voice.
My settings are the same they always are.
It's breaking up for me as well, Mark.
Okay. Well,
so there's your
I don't know
theory.
what to tell you. Yeah, but if you ask people, let's ask what the people are hearing. No, it's not. If you guys can't hear me, if I'm breaking up for you, let me know.
Just
I can
sounds
hear
like
you
your
very
voice
well.
is in the wind, maybe.
Yeah,
Oh,
I
you sound
understand that.
choppy.
Yeah.
Okay. Does this help at all like this in any way? If I just like this, does my
No.
voice sound choppy?
You're still choppy.
Okay.
Maybe
All
it's
right.
Skype.
Okay, yeah,
I
maybe
think
it is
that-
Skype.
Well, Donald Kunzer says it's not Mark, but the app you are communicating with. Yeah, okay. But, so Skype is having an issue between us.
Yeah, chat seems to be hearing great, which is really the most important.
Yeah, but let me just check something here, though.
Okay.
Let me go into my audio and video settings, and let's see. Okay, I'm going to try something a little different. All right. Let's see if this works, guys. Okay, can you still hear me?
Yes.
Yes.
Okay, and am I chopping up anymore at all?
No.
No.
Okay, then I'm still coming out. That's all that matters. So I think maybe that is fixed.
That sounds much
See
better.
that? We can fix
Yay!
everything.
Thank you. Ta-da! It's
Yeah.
that magician in you.
I guess. So in the time that we've been sitting here fixing sound, we've stacked 16 of these images. And that means now that we actually have a sandwich of 16 images. And that means that in between the stars, in the darkness between the stars, we have a lot of very dark sky. We don't have a lot of the noise that you might associate with this anymore. And that's pretty good. And that's what stacking does for us. It gets rid of all of this. Okay. The music is there, Izabela. I hear the music. Then it's going out. All right. So, let's see here. If I was to just drop this in like this, just a little bit. And then I'm going to darken up the sky behind the stars just a little bit. There we go. All right. And I cannot wait until we get Starlink. I hate Starlink for the fact that it brightens up my sky. But honestly, it'll be a godsend because it's going to change all the dynamics of how we operate. We're going to have nearly 1-to-1 speed. Right now I have a 1 to 3 second delay with every click I do. I'm actually running ahead of things, you know. Hey, Joel Sweatman, how are you? Thank you for coming by. Joel's saying hi to you, Tara.
I saw that. Hi, Joel.
Yeah. So my voice should be okay now, guys, and there shouldn't be any issues.
Yeah, it sounds a lot better.
It's just a matter of figuring out the right data sources for things. You know, I don't know.
Just got to get settled in. That's all.
Yeah. This is looking nice.
Beautiful.
That's not bad. Darrell, you've
Colors
seen
are
these
beautiful.
without... When you take the halos away, right? You see how that makes these look so much different?
Oh, yeah.
Yeah. Well, everything you've seen here on the screen so far is just part of it. We actually have something else in the background that we always use as well, and I'll bring up my main system here. We're going to bring this up. This is a system to focus our telescope, and I have it set up so that once we focus it, it tracks the temperature in the building, and as the temperature changes, it'll alter the focus, okay? Because that's what has to happen. It has to alter focus. Right now it's 58 in there, and so what we can do in just a little bit is when we go to the next object, we're going to just zoom right in and in those 1 second intervals while we're watching it develop on the screen, and we'll be able to refocus. Right now it looks like it's pretty good. You know, not bad. And just remember, folks, this is live. This is not a photostatic picture. This is a photo that's building stack image by stack image. You'll notice that the image gets better and better and better as time moves on. Look at this beautiful cloud of dust right here. We've got these beautiful arcs right here. Those are real. Those aren't parts of those aren't camera artifacts. You know? So there's a lot of really neat stuff here. I think the Pleiades has always been a favorite of mine, Darrell.
Oh, yeah.
Yeah.
Me too.
Okay, now.
For so many people in history, right?
Yeah, that's right. So this image shows us right here. This is a 100% size of the sensor. We actually have a lot more room on either side, a lot more sensor on either side, a lot more image on either side. Okay, this is at 100%. All right, and that means that if you were to take a picture and put it at 100%, it would end up being very, very large. If you were to print it, it could be a gigantic poster-size image. That's how big the sensor is in here. All right. So that said, let me zoom back down. We're at 100%. Let's go back just a bit. All right, and we're now going to come back to just capture the full size of the Pleiades here. And drop down just a little bit. Yeah. So like I said, look at these beautiful blue. These blue colors, as I mentioned, are because the dust in here, the stars are moving through this bright, this big dark cloud of dust. But as it does so, the starlight, which is bright and blue, is being scattered by the dust. All right, but only the blue light. The rest of the light, because it's more than blue light coming from these stars. You'll have red, orange, yellow, green, blue, indigo, and violet in most stars, but just less red in these stars. The red end is very, very small. All right, but you do have it. So it's pretty cool watching this develop like this. So that said, let's go back to our planetarium section. And hello, Richard Spencer. I guess you're up in the Great Lakes, huh? Well, yeah, it must be chilly up there. Tim F., what's happening?
In Phoenix, we call that freezing.
I think we call it that too here. So I think it's sort of a universal.
You think so?
Yeah.
I don't know.
Yeah, I think so.
We call 70 freezing too. So.
Mark, can I comment quickly while you have Stellarium up there?
Yeah, sure. Go ahead.
Okay. I mentioned this during the radio show tonight. If you look there near the middle of the screen, you see the star Aldebaran, which is the eye of the bull in the constellation Taurus. And if you see that V shape of stars next to Aldebaran, that's called the Hyades. That is the closest star cluster to Earth. It's about 170 light years away. Now, Aldebaran does not actually belong inside the Hyades. It's a foreground object. It's about 70 light years away. The Hyades cluster itself is about 170 light years. And then when you look to the upper right and see the Pleiades, well, it's the next closest star cluster. It's about 400 light years away. So you see Aldebaran at 70s, the Hyades at 170, and the Pleiades at 400. And that's giving you a very three-dimensional look out into space right there.
That's right.
If you can visualize that.
That's cool.
Yeah. See the distance given in here. Distances in this particular product are not 100% accurate. This says 382. It gives the distance to Aldebaran at 66. So these stars are a lot further away. So they're like way out here compared to Aldebaran way up here. See, so we have a full 3D universe that we're playing with here. And everywhere you look, you're looking either at something that's drastically further away or closer than you thought it was. And you're always looking back in time, no matter where you look. And that's something that I find interesting, too. It's like a time machine.
So are we ever not looking back in time if we have, like, telescopes just looking at the moon? Or
No, we're seeing the moon as it is just a second ago. Just about. We're seeing the sun 8 minutes ago. You're seeing if we're standing in front of each other, you're seeing me a fraction of a nanosecond earlier, or later than the time the light left me, reflecting off of my my face. So everything's a time machine. Everything is a look back in time. Everything. It's just with
So-
the universe, with distances so vast, that it becomes really, really clear. You know, it's clear that that's happening. But you were going to say, I'm sorry. Go ahead, Tara.
No, it's kind of on that same line. So is there a place or a distance that differentiates near space to deep space?
Well, we could do that on a variety of levels. Okay, for instance, we could talk about, the fact that near space could be, say, the Hyades cluster. All right, and deep space could be a much more distant cluster. Right. Okay, like this is Hind's Variable Nebula. Okay, it's a really interesting object. All right, and its distance is 3,262 light years away from us. Yet the Hyades right here, this V shape, these are only a few tens of light years away from us. Right? I mean, just 166 or whatever light years away. So we're looking at something that's thousands of light years further away, and it looks like it's right next to it in space. Isn't that crazy?
It's
Yeah.
so cool. Yeah.
You know?
Terry, you might think that, you might say, when we're inside our solar system, okay, that the sun, the earth, the rest of the planets, you might say that's near space, and everything else is out there. When we look at things like this, like the Pleiades, they're called deep sky objects, implying that they're
Right.
far out.
Right.
Well, they are far out compared to where we can go.
Yeah.
You know, compared to where we can go.
Well, we really can't go anywhere right now, right?
Well, soon we'll be going back to the moon, and soon we'll be going to Mars.
Cool.
And soon we'll be able to peer into the hearts of dark nebulae before long. You know? Hey there, one man.
Whoa, James.
James Dugan is here from down under. Vera Lucia Campos, how are you from Brazil? Good to see you.
Hi, Vera.
Nice to have you come in. So, I think one nice thing to do is we're going to end this stack because we have 60, coming up on 60 stacked images here, and that's more than enough. And what I will do is do what I always do. As soon as I finish, the stack's now paused. You see that yellow bar up there, it says so. Now I'm going to hit save, and save is going to put another line across here in green that says it's saving a file with a really wacky name, but it ends in .fits, fits. That's an astronomical image format. Now you might say, well, how can I see what those are? Well, you can. There's free fits programs to actually look at them, but I'm going to save you the trouble, because what I'm going to do also is save this exactly as we see it here. All right? So just like it is as you see it with your eyes, that's how it's going to show up. And you're going to say, well, show up where? Well, every image that we take, every single image, and every stack we take, they end up going to our server. Our server is a active server that allows you to go view these images 24 hours a day, and you can go check them out, enjoy them, download them for free, and you can enjoy these images forevermore. They, as I said, they're huge, and you could easily print them out and or do whatever you like with them. Put them on your desktop background, port them over to your phone, anything you want. Hey there, Zadarek. So they're free for you to do, and they're courtesy of SkyTour Livestream. You know, we believe in science being for everybody, so these are free for you all. All right, so that said, we're going to take off and go to another spot. Now that I've done this, I'm going to clear this. It's going to look like it's gone away, but it has not. It will not. It's going to be on the server. In fact, the directory on the server is probably already made, because as soon as it gets finished being taken, it goes up to the server. Hey, Genghis. Genghis is here. Nice to see you. All right, and so now that is our live shot again, but it's a 15-second shot. Let me get back down to 1 second intervals here. And this section over here I was telling you about before, if I was to slide this over, that yellow line is going to intercept more of the data. This is the data you see coming down, the red, green, and blue lines. And as if I take this now and I slide it over, okay, then that yellow line is going to bow up and intercept more of the data. And thus, we're going to see more of the data on the screen. See, that's how that works. See? All right. And so what we do is we actually do increase the data. And I just hit this one key to do it. It's actually kind of a immediate jumped up to high well, I would say resolution, but it's a high sensitivity, and it allows you to see everything live. So you can actually see the noise. It's a 1 second exposure, so you can see the noise. If I zoom in, I can show you that really easily. All right, so let's do that. So I'll go to 100% right now. 100% looks terrible if you don't stack, okay? So look, every second you see the noise changing, but the stars stay right where they are. It's the noise, this color banding, this color blotchy, all that stuff, that's changing, and that's what gets removed by stacking. See? And we end up with a beautiful, pure photo at the end, and that's exactly what we're looking for. So that's how it works. Bet you knew all that already, Tara.
Does that ever remove any thing it shouldn't? The noise? I mean, how do you know it's not removing data from your stars and stuff? Like dark matter?
Well, because of consistency, with what's behind it. Say it's a very faint nebula, okay? A very faint nebula, right? A very faint nebula, you might say, well, wouldn't stacking possibly smudge out some of the details there? The answer is no, because if the faint nebula had 5 fingers of nebulous detail that were all dark and very, very hard to see, the more you stack those, the more signal they have, the more bright they become relative to the noise in between, because that never changes. That changes moment to moment. But this dark data in here, that just builds. So it keeps making mountains of the data, and in between the mountains, like in between the stars here, those become the hollows, the down below, the valleys, and we don't care about that. Even dark data builds, and actually I can show you that. We can actually see it happen. First things first, I'm going to actually get our system up here, and now what I'm going to do is I'm going to take us, while we're thinking about it, I'm going to take us over to Hind's Variable Nebula. All right, and I'm going to tell the telescope to go, and our telescope is up right now in the Pleiades, and it's now going to move. You're going to see it move over my head, and you're going to see the telescope moving right here. So it's moving to a location where it's going to find a star that's going to use sort of a guide star to take it to the object we're asking for. It's called high precision pointing. And right now we're going to theta 2 Ta, or theta 2 Taurus.
Looks like silly string.
Right?
It's a party in space.
Yeah. Exactly.
I found a can of silly string. I have no idea where that came from.
Wow. Some party you don't know you're in. This is Aldebaran that we have in here now.
Does it still work, Darrell?
I don't know. That's a good question.
Well, what you do is you point it right in your face and you pull that little push down. No, you don't do that. That's crazy.
Yeah.
I would say not. Okay. So here we are, and I think we're parked over Hind's Nebula. Let me just make sure. Let me also bring up this guy here. I've noticed that some of the coordinate systems in the telescope sometimes are messed up sometimes. And it's not my doing, it's just actually what we just have to deal with. But what I can do is I can actually move us a little bit, I think, to the west. Let me see if that's the right way. Yeah. Okay, we're going to go to the west here a little bit. And pull in on Hind's Nebula. And then go south. The telescope knows where it's going, but it depends on whether the telescope has a a database that's valid. Sometimes the database data is not valid, and that can screw things up. Not my fault, but it's just what has to happen. What happens to the telescope? So let's see now. Looking for a Hind Nebula. I probably have to.
And
What's that, Darrell?
sometimes you do need to sync up on an object, though.
Yeah, that's exactly right. And I think what I'm going to do is I'm going to tell it to go to Ain here. All right, this is Ain. It's a star. It's nearby.
Aiming at Ain?
Aiming at Aim, or I'm aiming at Ain. Yes.
Aiming at Ain. With
Yeah.
silly string.
So we're gonna get it right in there, and then we're gonna sync, because sometimes I just have to actually make sure the telescope is pointing where I think it's pointing, or where it should be pointing, because it doesn't
That's the
always do
bulls.
so.
That's the bull's other eye,
Oh yeah,
Oculus Boreus.
Ain.
Says it right there in Stellarium.
Oh.
Oculus Boreus, northern eye,
Okay, I guess so.
where
Okay.
Aldebaran is the southern eye, I guess, and
Mm-hmm.
Ain is the northern eye. You know, the bull has two eyes.
Yep. Mm-hmm.
All the better to see you with.
My dear,
Arr.
my pretty. Yeah, you know what's funny is I think when I was looking here, I noticed that it was saying that Aldebaran was theta 2 tau, and it's not theta 2 tau. So I think I just need to tell the telescope where it is, because right now it thinks it's somewhere else. I should have Ain down here to the lower right. So if I go down, I should see a star that's relatively bright.
Couldn't go wrong syncing on Aldebaran.
No, I know. I'm going to, actually, if I can't get this to work right. Oh, didn't want to do that. I want to go this way. Yeah, that's odd how that sometimes does that. Okay, here's Ain.
Oh, it's much brighter.
All right. Yeah, it is. When it's horizontal like this, when you see these time exposures here, what those are actually ways to, of course, besides being the stars being dragged out, what they are as well is ways to see the colors of the stars. You can't tell what color these stars are, but sometimes if you let them drag out, you can actually see the colors pretty clearly. Hey there, Kyle. Kyle Lynch is here. What's up? Okay, so there's Ain right there. And it says that our coordinates are 4 hours, 27 minutes, 52. And let's see what the coordinates of Ain are according to this. All right. So, number one, we're going to center up on it. All right. And Ain, 4:28:37, 4:27:52. That's pretty close. Yeah, and so what we have to do is we can do a number of things. We can actually do a plate solve right here, which is kind of cool to show you. We can actually let the telescope tell us exactly where it thinks it's pointing at, and then we can use those, put those coordinates in right here, and tell the telescope to take on those new coordinates. So we're going to plate solve right now, and in the process what I will do is bring up something that can capture that. Should be relatively quick, I would think. Go away. There we go. And then we'll get on with the business of showing you some cool stuff.
Izabela said the
So-
image is uploaded real quickly today.
Oh, good. And see this? We already know exactly where we are. The telescope identified where it's pointing. And it says we're at 428.37, which is actually not too far away. And 1911.39. So I'll just put those coordinates in anyway. Over here, we're going to put in 04, 28.37. All right. And then we are at a positive angle. That 428.37 is the east to west motion. Okay, that's the east to west. And the up and down is the declination, it's called. And that's the 11.39. All right. So now I just say sync, and we should watch those coordinates change, even though the telescope is very close. Yeah, see? Now it's changed. It won't be exact, but that's just because of the motions. Okay. So that said, we are and have been in a position to actually do this. I don't know why it didn't do it before, but that's what it did. All right. So let's go over to Hind's Variable Nebula. I'll do it from Ain, even though I can just drive over to it. Maybe I'll just drive over to it for this one. That's fine. So we're gonna head.
Are you using the
west.
Alcubierre drive to go over there?
You know what? Effectively, yes, right?
Kind of.
Effectively, that's what I'm doing. We are. All right, let me. Okay, let's do this now. In reality, to go from Ain to Hind's Variable Nebula would take thousands of years with our current capabilities. But if we had an Alcubierre drive, then we could get there in probably a few weeks. Maybe, just a few weeks, I would say. All right, let's go check out Hind's Variable Nebula. All right, and one thing I'm going to do first is, I think it's right there. I just have to do a 25-second exposure of this guy. And now we're going to go in and do a stack. And we should see something right there. I think that's where it is. So we'll see.
I can't wait. I'm waiting.
I can't either. I mean, technically, we're exact. We know where we are. It's just that I'm trying to get the telescope to register where it is. It should know where it is because we're almost there. Okay, there it is. It's there. That little thing you're seeing right there, that's Hind's. That's why it was so easy to miss. Okay. Now, couple things have to happen first. All right, I'm going to fix the colors, or I'm going to do a color correction right now. All right, so let's get the color correction. Okay. There it is. And let's do a slight process change to help show that up a little better. Because what this is, what Hind's Variable Nebula is, it's a variable nebula, and you'll notice something interesting in this image. And it starts right around here and moves all the way through to here and comes up to there. Do you see that? That's a very interesting finding, and it's something that we see all over. Not that. It's something that we see all over the place in the night sky. We see tons of this, and what it is it is a dark dust that's out there, and save for the illumination by a nearby star, okay, or a star that's exciting it to glow, like in this case, in the middle of that star there, you wouldn't know it was there. Okay. So this is a dark nebula and an emission nebula. Now, what that means, right, is that this part of the nebula right here is an emission part right there, right? And we can see that when I zoom in a little bit. Darrell, you remember we did this the other night, didn't we?
I don't remember. Well, yeah, I remember we looked at the Hind's Variable Nebula. I don't remember the details.
Okay. Yeah, that's the Hind's Variable Nebula right there. And it changes brightness because of the fact that there are this star here, this star that's in the middle of it, is a particular type of star that's very well known to us astronomers. It's known as a T Tauri star. In fact, it is T Tauri itself. It's the namesake for that special kind of star. You remember that now?
Yes, I do.
And yeah, and so you'll see this noise, this color noise. Again, that's going to go away as we take more images. So this is a beautiful location because that star is a young star. And they're well known to be variable and be wildly pulsating in brightness. And so that star was born inside this dark cloud where most stars are born. Actually, all stars are born inside dark clouds. And of course, then they cause the clouds to brighten. And sometimes they are so strong and powerful with ultraviolet radiation that the hydrogen gas in the cloud ends up glowing. And that's what you're seeing here. And that glow comes from ionizing the very simple hydrogen atom that was in there before, right? And it takes the electron off the hydrogen atom, and when it comes back down into the hydrogen atom, it glows red like this because the electron gives off a little bit of light. So you're seeing the accumulated light from trillions upon trillions upon trillions of hydrogen atoms that are bouncing back down into this nebula, which itself is got to be close to a light year across at least, maybe a little less.
So Hind's Variable Nebula is variable because the star is variable.
Right.
Compared to Hubble's Variable Nebula is variable because of what is it? It's shadows in the cloud, isn't it?
It's another star that is, and for those that don't know what Hubble's Variable Nebula is, we'll hopefully get a chance to see it tonight. Hubble's Variable Nebula is a really cool looking nebula, but it's not an emission nebula like this. It's not causing hydrogen gas to glow. It's actually a nebula that is shining by this reflected light that we talk about, and it changes its brightness. The nebula changes its brightness not because the star is variable like this one, but because, as Darrell just said, there's dark dust that's actually orbiting this star. Think of it as, say, billions upon billions upon billions of asteroids in clumps. Okay, for instance, as they go by the star, the star then casts a shadow of all those many asteroids, say, on this area of the nebula, and so it looks darker for a period of time. And Darrell and I remember we both actually seen Hubble's Variable Nebula looking very different. It'll be interesting to see what it looks like tonight.
Yes.
Because we saw it the other night, and we'll do it again. And if you do that over the course of, say, like, every 5 days or 4 days or so, you can actually gauge and watch and put together a little movie of the change going on inside Hubble's Variable Nebula.
Yeah, we've done that in the past, and to see something, larger than a stellar scale change in such a short time period is almost unheard of.
Yeah, it looks it's really cool looking. It's really interesting to see. But again, this star here is literally the poster child, the very poster child for the young hot stars that we see in the Orion Nebula.
Hey, Mark.
Yes,
Linda
Tara.
had a question. How many stars
Yeah.
are inside the nebula in total?
Oh, that's a good question. I mean, besides the one we can see, there are more that we can't see that might be in the process of forming, but then there might also be some that are, even though they're bright, they might be behind a wall of dark dust that's too dark for their light to get out. And we see that with Hubble's Variable Nebula. We don't see the star that's causing that particular nebula to change brightness because it's buried behind dark dust and we can't see it. You know, so the James Webb Space Telescope could look here, however, and it could tell you whether there is a planet or a star in here. It can find all of those things with its infrared systems. The infrared systems go from 6 microns, 6 microns out to 24,500 microns, which is, 600 nanometers out to, the equivalent 240,000, 2.4 million nanometers. It can actually go out pretty far in the infrared and see everything that we can't currently see. So if you look, you can see this cloud now is starting to show up a little better, but I can actually make it show up even better. I'm going to do this. I'm going to darken the background stars against the nebula and show them a little bit better, I hope. Oh, that was almost it. I went a little too far. Alright, how about that? Oh, I went back to where I was. It's not what I wanted to do. It's that 1 second delay, guys. Just give me a moment here. Let's try that.
Tara, in Mark's Skype screen that he's sharing with us, do you see the chat display down at the bottom right-hand corner?
Well, I see a bubble that says chat with the red dot.
Uh-huh. Click on that bubble, please.
Okay, I did that. Okay. Thank you.
Okay, now if you just click the X up at the top right, you can close that chat window again.
Okay. Thanks for the tour.
Hey there, Pete Bods. Thank you for that, Darrell.
Sure.
Another thing to notice in this beautiful developing nebula that we're seeing here, check this out right here. There's another star in there. I don't recall seeing that star before. It looks actually very interesting. See that star right there?
It's very
Which
red.
one?
This one, the red one, under my cursor.
Oh, yeah.
I don't remember seeing that star before. It might be a red dwarf. There might be a red dwarf, but that red color could also be due to the fact that we're looking at it through all this dust.
So it's clearer, maybe, or something? Or?
Yeah, you know what would be cool? It'd be so cool if while we're watching one of these nebulae develop, we actually saw a star wink into existence for the first time.
Yeah.
That's a history-making thing. So I'll have to go into the SEDS database and see if this star was there, because I don't remember it there last time. It might have been there, but we're so used to the universe not changing, but it does change all the time. You just have to know where to look, and mostly when. I know we. I don't think you were there for this, Tara. Were you with us for the lunar eclipse? That amazing night.
No, I missed that amazing night.
Oh, that's too bad. Hey, Dagger. We had, it was back in 2019 in January, there was a lunar eclipse when the moon was going into the Earth's shadow and it was turning like blood red a little bit. And at the height of the eclipse, when the moon was reddest, we caught a meteor strike the moon. And now you might say, well, how could you even tell? And worse is you would say, well, how could you tell, that it was a meteor or anything else? And when you find out the details, that this meteor was like less than a foot across, or just over a foot across. From 240,000 miles, you can't expect to see that. And that's true, you can't. What you can see, though, is you can see that kinetic energy, the energy of motion of this very, very fast-moving meteor, strike the moon, come to a dead stop. And when it comes to a dead stop, all that energy has to go somewhere. And what happens is it gets converted to heat. And so we saw the flash of this meteor striking the moon. It was so cool. And only 5 other groups on the Earth saw it at that time. So we were really happy to see that. Thank you, Dagger. That's very kind.
Meant to be.
If I remember right, we didn't even notice it at the time. Somebody else came into the chat and mentioned it to us, and we went back and found it.
Yeah, I saw it when it happened, and I thought it was just a glitch in the camera. And it turned out to not be a glitch in the camera. It was a history-making image, so I thought that was pretty cool. But that's how it is. And we talked about that in the show tonight on SkyTour Radio. Most discoveries are serendipitous. They're accidents. Mm-hmm. And this was an accidental discovery. Go ahead, Tara. I'm sorry.
Oh, no. I was just going to see if you were going to write a program to get rid of it, because you thought it was a glitch.
No, not at all. Not at all. Izabela says, I saw an angry pixel come into existence. That's funny. Hey there, JSEO. Jesco, 77. Alright, so we're going here. We've stacked 31 images. That's enough for this guy. We'll go back to auto mode here.
Tara, that meteor strike on the moon. Mark actually has that noted on one of his past streams. If you go back and look at, if you go look at the SkyTour live streams main page, that's noted on there.
Actually, I titled it with that. Yeah.
Cool. I know you.
Amal, what's happening? Yeah, I have, but that's pretty cool. Will SpaceX crash on the moon be visible to us? I don't know if SpaceX is going to crash on the moon. I do know that there's going to be a lot of eyes looking at the asteroid where DART is going to collide. But they won't see anything. They probably wouldn't expect. But they might, that depends, because the DART probe, I think, itself has cameras that are going to be able to record some of these things just before impact and stuff. The lunar impact, where a rocket body's going to hit, that's the SpaceX one, right? I think they were saying it's actually going to land, it's going to hit on the far side of the moon. Yeah, I don't think we're going to see that. Well, I know we won't see if it's there. But usually they go for the poles to actually see if there's ice. And if so, that's not an impact we'd catch, because it would typically be deep inside of a crater that's never exposed to sunlight. And they check the spectra of what gets blown up, and they see if there's any kind of water molecules and or hydrogen or oxygen that can be shown. And if so, then that's indicator that there's water there. Okay, this is Hind's Variable Nebula, and we're done with this. And I'm saving the FITS file. It's going up to the server now, and save exactly as seen. Izabela, are you able to put up the address of the server for people? It's in the description too of the stream, but don't worry if you don't see it here. It's in the description.
I think she did that already.
I bet she did.
Somebody did. Yes, she did. She put the image of the Pleiades up there once you finished that.
Oh, okay. Fantastic. Mm-hmm. Thank you, Izabela.
Yes, thank you. You're awesome.
Okay, stack's been reset. And we're going to go back down to... There it is right there. Thank you. Yeah.
Thank you,
Izabela Melamed is...
There it is.
Izabela Melamed is one of these people that is just a gem. She just comes along, and out of nowhere, she starts doing things for the stream and for SkyTour, which is just incredible. And what she does is she categorizes everything we do, and she writes notes, and then she creates a table of contents for every single stream. You can't buy that capability. Okay, not with the diligence that she takes and pays. It's just incredible. So a public thank you to her.
Thank you. Yes, thank you.
Yeah.
That's so cool.
Yeah.
It takes a village. It takes a team, you know?
It does. Humpty Bumptable, what's going on? Hey. Yeah. Oh, are you in Arizona? Where are you in Arizona? That's okay, Izabela, you deserve it. Okay, let's go take our image and let's do our hypered view that I call it. And now we can actually start to look for the next object here up for bids on the Price is Right. Okay. So we come in here and we're going to back out a little bit and we'll just get rid of our selection. And what do you want to see next? My oh my, I have an idea.
Door number 1, door number 2.
Oh yes, I mean
That's
Orion
right.
is right down here, but we're waiting for Orion to come up a little higher. But I do have one thing I would like to look at. I've been checking it out as a constant, and we're going to do it again. And we'll spend just a little while here, and then we'll go on to the next. Because we are actually looking at some really, really good imagery for tonight, I can tell you that.
It's the crab.
It's the crab. The larch.
Excuse me
Now
just
watch.
a moment, please. I'll be right back.
Okay, alright. When this star gets centered, you might actually see the crab up in the upper right, because there it is. Okay, it's using a star near the crab as a signpost to get to the Crab Nebula, which is right there. Isn't that funny? So then you're going to see this come down and go right here. Okay, here we go. Boomba. The crab is a supernova remnant, which was first seen by Chinese astronomers in 1054 AD. And this was in the sky for weeks, and then still visible in the night sky for a year after it occurred. And what is a supernova but a exploding star? A star that has run out of the primary fuels to keep it up, to basically keep it intact. And so the star would collapse. Gravity wins. This massive body collapses on itself. And it hits and bounces off this core, essentially, and makes this explosive result that you see here. The Crab Nebula has been observed for well over, several hundred years already. And it's been seen in telescopes all over the world. Thank you, Izabela. And now, as we come down here, you've seen the Crab Nebula, haven't you, Tara, or no?
Sorry, I was on mute. Yes, I've seen it.
I
It's
thought so.
beautiful. It's cool.
Yeah. I'm going to zoom in now to see if our focus system is still good, because I have not played with the focus yet at all, and I will fix that and then set our focusing system on live.
Hey, Mark.
Okay.
Hump,
Yeah.
Humpty said he's on the Hopi reservation.
Is he?
I'm not sure
Wow.
it's he, so pardon me if I'm wrong.
Okay.
Yeah, so cool, huh?
That's funny, because I knew a Hopi named Thomas Beniptua. And that's why when I saw Humpty Bumptua, I actually thought about that. But I didn't say anything, because of course you never know.
Right.
Yeah.
Well, we're glad you're here.
But Tom was a Hopi Indian. But I saw him, gosh, it was 30 years ago when I met him, so yeah. Well, it's wonderful, Humpty. I'm glad to see you. Now, Hopi Reservation, is that northeast of you? Is that up north?
It is northeast, yes, that is correct.
Okay, I thought so.
The parts that are in
I
Arizona.
thought so.
Yes.
Yeah. That's wonderful.
It's beautiful out there.
Yeah, I'm just watching the star quality and just checking the focus. Looks like it could use a little tiny bump, but I'm not sure, so I'm going to check it out. Okay, you'll bring it up. And usually the bump goes down when the temperature is. So we're going to go down. There's one. That's a lot. Let's see if that does. That looks like it works. That might be... I'm just watching for my focus, guys.
It looks like... Genghis says it kind of looks like Fire Opal Nebula. Look at the pretty colors in that. I think that's the one he's referring to.
Yeah, that is a very pretty nebula. It really is. I'm going to go way out of focus here for just a minute. Okay, so now we're out of focus. And I'm going to come back. Okay, I'm bringing it back. We're bringing it back. We're bringing it back.
What goes around comes around, and everything comes back.
Fireball! Bum, 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 bum. Yeah? Okay, so this looks like we're okay. Hey, Amal, thank you, man.
Thanks, Amal.
Amal's funny. January tuition. If I charge tuition, that's okay. Thanks, man. Thanks, brother. That's very kind.
That's really awesome.
Okay, this looks okay. So what I'm going to do now is I am going to turn on and enable our temperature compensation system now. So now, once this is on, now all of our focusing will be done automatically based on temperature at the moment. So there we go. So that's good for now. And now what I'll do is come out of here. All right. And this is... We're going to go to auto mode here, which is going to fill the frame. There we go. Alright, and this is going to be the Crab Nebula, which is a supernova remnant. Crab Nebula right here. Okay, folks, let's take an exposure. Let's get some images. Here we go.
Let's get some images. Cool.
Right.
Tara, per our talk earlier tonight, if Mark, could you pull up Stellarium again for just a second?
Yeah, let me just finish getting this set up here.
Sure.
All right, so that's set. I gotta set up our timing here. All right, and we're gonna do a 25-second exposure here. Oh, Humpty Bump. I see. That's a nickname my younger brother gave me. Like Humpty Dumpty, I fell 2 stories.
Oh,
Used to be a roofer. Oh. Hey, Humpty, I'm glad you're still with us, man.
Oh my gosh. People fall off roofs.
I know.
I've known people who've done that.
I know what. I haven't ever fallen off a roof. I mean, I've almost fallen off life a few times, but okay.
Well, we're glad you're still here with us, too.
Me too. Okay, we're going to bring this 25-second exposure back down to something that's a little bit more viewable, something a little nicer. So let's do this. We're going to bring this down a little, and once I do that, Darrell, I think I'll be ready to go to bring up Stellarium now.
Okay.
All right.
Ooh,
Thank you for your patience. It is. Let me actually make it a little bigger, too, before I jump to Stellarium.
Pretty pretty.
We'll go to 50% right now. of the frame. So we should get a bigger view. There we go. All right. And now Darrell wants Stellarium. Darrell wants me to cover it up, guys. His fault.
Well, for just a second. Tara,
Sure, go
if
ahead.
you see Aldebaran there on the right, and you see where Mark's scope is pointed at, their little left to center,
Right.
they're pretty close together in the sky. And when you see Aldebaran, again, that's about 70 light years away. And when you see that whole V shape of the Pleiades, that's about 170 maybe light years away.
66, yeah, 170, yeah.
Wow.
Yet when you're looking at the Crab Nebula there, that's about 6,000 light years away, if I remember correctly.
Yeah.
Wow.
So it is much, much farther away.
Wow.
Thank you,
Yeah,
Mark. Go back to
65
your
Thank
pick.
you, Darrell.
Yeah.
And thank you, Mike. Cool.
No, yeah, sure. About 6,500, according to this. But one of the things to notice is, let's zoom in close now that we might be able to see it. I'm going to go to 100% of the frame right now. All right. And right there in the middle, you see that little dot at my pointer? You see that little white dot right there?
Yes.
Okay, that white dot is 6,500 light years away, 6,500 light years away. And that little white dot is the size of Manhattan Island.
Wow.
Okay? 6,500 light years away is the size of Manhattan Island. Now
How
think
dense
about
is it?
think about something on the moon, right? If you had something on the moon the size of Manhattan Island, it would take quite a bit of your telescope's power to see that object just 240,000 miles away on the moon. Now take something and move it 6,500 light years away, the size of Manhattan Island. The actual size of it in the sky is minuscule. But this is a neutron star at the core here. What we talked about in tonight's show, SkyTour Radio, we talked about neutron stars that orbit each other and sometimes they collide, and that's where gold, platinum, and other precious metals like silver and stuff come from. You actually have gold in your bloodstream, like 0.22 cubic millimeters worth, if you're to make a little cube of it, right? And that gold comes from when stars like the one here in the center of this supernova remnant collide with others just like it. And that happens often because many stars are binary and will circle each other for billions of years, millions of years. And then one goes off in a supernova, leaving a neutron star. And then the other one goes off in a supernova, leaving a neutron star. And then that disrupts their orbit enough so that they end up getting these really wild elliptical orbits until they actually collide. Boom! And they explode in something called a kilonova. And those shower the interstellar medium with gold, platinum, silver, iodine, and of course bismuth, which is in Pepto-Bismol, as we talked about on the show. So when you take Pepto-Bismol for an upset stomach, you're actually taking a substance that was forged in the collision of neutron stars. For real. This is real. So that is a very interesting finding here. Really cool stuff. And Humpty, you said something earlier that I didn't miss. You said many people believe we come from the stars. That's true. That's true. There's a lot of people that think we come from the stars, and I don't doubt that there is. You talk about the Hopi believe we come from the stars. I have no doubt. In fact, you do come from the stars. There's no doubt about it. Everything you're made of, every single atom that's in your body, was made in the heart of a star and brought back to the universe via something like this right here. Okay, this supernova. Okay, so at the very least, Humpty, at the very least, okay, but at the very most, well, then there could be something more to it as well. Some people believe that the human race was brought to this planet, and I don't know if that's true, but I can tell you that there's enough information out there that I would feel that maybe we evolved here, and that maybe there is some type of interference or, say, influence from the stars. There's a lot of cultures that talk about this in Australia, in the Kimberley region of Australia. We have the Wandjina, which were rumored to come from the sky, okay, live in the water, underwater, and have command of the water. So they were true star people as well. I don't think it ends there. I think that there's more possibilities all over the world with different cultures that may have been influenced by otherworldly things. Give you an example. I did a talk in Denver, Colorado a number of years ago because I had noticed that, and now you see it all over the place, I had noticed that in a lot of cave pictures, Renaissance art, paintings from Australia, all these separate cultures that never talk to each other, they show their gods or their deities with halos around their heads. Now, I thought that seems odd. Why would they do that, right? Why would they show a halo around their heads? I think it's because it was something that could have been observed. Maybe there were visitors. Maybe that halo was just a germ filter. Do you know we're actually looking at ways to do that same kind of thing now? Create an electrostatic field that protects us without having to put a faceplate. Think about it. If we can think about it, right? If we can think of it, then some other civilization may have already. I have to say hi to Jesse Peak. What's going on, brother? Jesse Peak is in the house. What's going on, man? Hope you're doing all right. But yeah, if you take a look, this supernova remnant is shaping up nicely. Look at all those filaments. Look at the colors. This is all oxygen throughout here. The greenish glow is from oxygen, doubly ionized oxygen. Different atoms have a different number of electrons that they have, and sometimes, depending on how many of those electrons can get bumped off the atom with high energy, that's called ionization. When they recombine, they might actually give off light of a certain kind. The predominant one that oxygen atoms give off when they doubly ionize and the electrons come back is this greenish light. So we see this beautiful light. Then hydrogen gives off this gorgeous red glow. Hydrogen emission, very, very, very obvious. But I'll tell you one thing. That region here is very hot. Very hot. Hey, Susie Cat. And now, that dot I was telling you about before, that neutron star in the middle there, is actually a neutron star of a special kind. And it's called a pulsar. And a pulsar in the Crab Nebula is actually spinning very rapidly. These stellar remnants, these stellar supernova remnants, are so compact that a teaspoonful of these things would weigh over 1 billion tons on the planet Earth. Okay? A lot of stuff in there. But they're spinning very fast and rapidly. This one is spinning 33 times per second. That's something the size of Manhattan Island that's spinning 33 times per second. That's pretty big. That's pretty fast rotating.
How can that happen? Yes, it's crazy.
And it's not the fastest.
If you took that teaspoon of neutronium from the neutron star there and brought it to Earth, it would dissociate violently, more violently than you could imagine. It would probably blow a pretty good-sized hole in the planet.
Yeah, it's what's called degenerate matter. So the only thing holding it in place is the extreme gravity of all the other of the mass, the total mass of that neutron star. You take that away, and it's going to go off. So there's actually no way to transport it, to be honest. So you're safe from neutron star bombs. Okay. Just want to say to Jesse, congratulations joining the Planetary Society. I saw that message go by a little while ago. Well done, man. Well done. Lunar and Planetary Society is actually a very, very good organization. This is great. We've got 24 stacked images here. Look at that. I actually think we're getting more detail tonight than we ever have. Look at how detailed this is.
It's just gorgeous. I want a ring made out of that. Like a stone.
Oh, that'd be something else.
Pretty? Mm-hmm.
Yeah, let's go up to 150%. We're at 100% of the image right now. Let's do 150. Look at that. Wow.
There's so much going on.
There really is a lot going on here. Again, I do dare say, Darrell, I think this is probably one of the best Crab Nebulas we've ever seen.
One of, I'd say. The neutron star got a lot clearer when you enlarged it again.
Yeah. Remember, I also processed that down to get rid of the. We're actually overexposed here in the middle. I actually had to remove some of that data to get it down. You know. Humpty Bumpton says, our older villagers throughout the land line up with the stars. Even the three mesas line up with the stars. Yeah, I'm familiar with those alignments, Humpty, and I think they're really impressive. And I know there's going to be something to that. You know, my mother was Irish and Passamaquoddy Native American, so not Hopi at all, or not Navajo, not Apache, or any of the ones that people typically know. Yeah, so I've always been in touch with Native American people and kept astride of what's going on with my mother's ancestry. And so in her culture, there weren't really any of those alignments. They were more foragers, forestry type people. They actually weren't. They were never out in the deserts. They were never out in the land under the big sky, as I call it, out in Arizona. But I think that it's pretty cool. I think that's very, very nice, and it's I admire it. Yeah. So Darrell, that looks like that neutron star, that pulsar is really, really cool. The thing about the pulsar is, you don't see it happening because it's happening 33 times per second, but it's actually spinning so fast at 33 times per second. It's actually flashing us with a lighthouse beacon. That's what the light is that you're seeing. It's so bright and intense. We're actually seeing a lighthouse beacon flash. All right, and in between, there's no brightness, not much brightness at all. But because it's happening over 30 times per second, it looks constant right here. But if I took a video of this and we slowed it way down and could capture it with very, if we could capture it at, like, say, 120 frames per second, or then within those frames we could see the dimming and the changing. And I've seen imagery of this, but you have to see it. You have to use special filters, a special telescope to see that light doing what it's doing, because it's really, really high frequency light. Yes, Humpty.
I believe there's video of that on YouTube. Give me a moment.
And I was waiting for Darrell to come up with the link. Yeah, it's really pretty to see it. You actually watch it flash. It goes, it's just flashing at you. And you say, what's it doing? Well, that's the star, the pulsar spinning. When a supernova explodes and the star is doing that, the stuff is moving outward at a very high rate of speed. And that high rate of speed as it's moving out is something that you can't see in day-to-day life, but over a period of 100 years you can see it, and we certainly can see the expansion of the crab over 100 years. It's really cool watching it. Now, but when you take a look at that spinning pulsar, when the supernova exploded, the star didn't explode evenly on all sides. It imparted more force on one side than the other, but you have to understand, so much force was applied unevenly to that core of the star that it set that thing moving and rapidly rotating. That rotation will continue for millions, perhaps billions of years. And there are spin down rates that things will eventually slow down due to other kinds of losses. However, this spin down rate is something that takes a long, long time. There you go, Darrell. Let's go see if I can bring that up. All right, let's just quickly look at a left screen here. All right, this one?
The one at, okay.
Maybe we'll try it, I don't know. Oh, this is just a visualization.
Yeah.
It's not showing what we want.
All
right. Well.
If you go back.
Oh, this is okay, this is actually in what the heck? I'm actually in I don't use Chrome, so I have to get that again. All right, so I think this is the
Scroll
one.
down a little bit.
I think this is the one right here. Right?
That one's only 2 seconds
so.
long.
Yeah, I guess so. Now I'm stuck again. All right. Okay, well, let's try this again.
Go down.
All right. Let me get it again. I'm going to show you guys. I'm going to show you the Crab Pulsar. Is it this one?
There's another one that's about. That was the two.
Okay. That's 2 seconds. That's 51. That's zooming in. This one? 20 seconds? That's got to be it. We'll
Scroll
try
down
it.
a little farther.
I want to see the Crab Pulsar. I'll skip the ad, sorry. No. All right. Okay, well, that's actually a light echo of the Crab Pulsar as it affects the dust around it and the material around it. That's pretty cool.
Click on the one over on the right, 22 seconds.
This one? Where are we? What the heck is this? I don't have Chrome, so I don't actually understand how to go back in Chrome. That's silly, but it's true.
I just hit the back arrow.
I didn't see a back arrow. Did you?
I don't use Chrome either.
I can't find your link anymore. Here it is. Hold on, folks. We're still stacking. Don't worry. All right.
Okay.
So
scroll down slowly. There was one
right.
that was 50 some odd seconds.
Okay.
Crab Pulsar. Okay. Go down just a little bit more.
Not this one?
Crab Nebula Pulsar. Oh, you can try that one. I think that one is the one I think I looked at.
That one?
Yes, this one. Your pointer's on it.
All right. Well, let's go see. Okay. So there's the pulsar right there. And this is slowed down tremendously because it moves so fast that you would not be able to see the separate flashes.
There's a better one out there I've seen before, and it's in color. I didn't take the time to look at all of them.
All right. Well, that's great. Well, thank you.
Yeah.
Where is the camera? Okay. All right, just a second here. I'd like to know where my camera went. Looks like the camera shut down. Let's go make sure that's not true. Come on. Yeah, there we go. So I think we lost that. It's still here. It's still pointing at the Crab Nebula, but for some reason, we lost our view of it for some reason. So what we're going to do is we'll just restart that. It's not a problem.
All my fault.
Well, something happened along the way. I don't know if that was your fault. Okay. But I know that something moved. And let's see what's going on. Okay, so there's the crab. Still dead center. And the only thing we gotta now wait, because our temperature now is back up. Somehow the camera got killed in the middle, and I shudder to think that maybe I shut it down by accident. If I did, my apologies. You can hit me about the face and neck. Okay. And while we're waiting for the camera to come down, I'm just going to reposition a little bit here. Then we'll move on. See, what we're doing is we're waiting for the Orion region to come in, because once we get Orion region coming up, it's just, there's so many things to see here.
You should be close to the meridian with Orion by now.
We might. Yeah. Let's go see. All right, we're waiting. Cameras at 7.5 Celsius, down from 14 Celsius. All right, let's just back out a little bit. Yeah, and zoom in. And there's Procyon. There's Rigel. There is Orion right here. We're up here in the Crab Nebula. And we're going to see just where we are. Okay. There's Betelgeuse, the future supernova, which I can't wait to see. I hope it happens sometime soon. Darrell and I differ on that. He doesn't want to see it go. I do. I want to see a supernova. I really do. I mean, talk about nature's fireworks. We'll be streaming night and day.
You wouldn't want to see that, Darrell?
He would.
It would be fascinating to see. Maybe I would change my mind once I saw it, but I would hate to see Orion changed forever like that.
It wouldn't,
like I
though.
said the other night, if we want to see a supernova, let's see Thor's helmet blow up. That's plenty good for me.
Thor's helmet would be very exciting to go, yes. Thor's helmet is a Wolf-Rayet star, which is a very, very hot star in the final stages of life. It's blown off its envelope of gas around it, leaving a hot core behind, which you can see. And kind of like the Crab Pulsar, you can see. And that provides us with a spectacular front row seat. But Betelgeuse, how far away is Thor's helmet, that Wolf-Rayet star? Do we have a distance on that? I think I don't quite remember. Minus 0.3 C, we're on our way. We'll be back in a second.
I'll find out. I knew, but I forgot.
That's all right. I can't remember if Betelgeuse is closer or farther.
Oh, Thor's helmet is farther.
I think Thor's helmet. Yeah, I think Thor's helmet's farther away. And we will be able to see some really cool things tonight in Orion, so we're going to be going there shortly. That's excellent. Oh yes, the Orion Nebula awaits, folks.
Nebula is about 11.96 thousand light years away.
Okay. So it's about 12,000 light years away?
Yep.
All right.
And what's
That's pretty far.
About 700.
50, yeah. Wow. Like 20 times further. 18 times further. All right. This is going to be a beautiful night. So it's cooperating. Telescope is, everything's cooperating beautifully. I think we're probably going to be near a cooler temperature. Minus 4.9. I think that's pretty good to just start a stack. We're going to do a 24-second exposure and get off on my hypered finder view and just jump into the live stack. Now we'll see the live stack, and this is going to show us our object. Didn't preserve the buffer from the last time. Where'd it go? There it is. Okay, I must have killed it. All right, so we come up and clear it, and then the very next image is going to be our first Crab Nebula shot. Okay, stack reset. There we go. Yeah.
There it is.
It has returned.
It's still pretty.
It's still beautiful.
Mm-hmm.
Yeah, so what I'll do
And
is I'm going to go
green.
right to 100%, and I'm going to drop down our... See this noise back here? Watch how it changes. Ready? Watch it go away. I don't know if you caught that, but that color modeling, much of it went away. That's what stacking does. It gets rid of that noise. All right, let's drop this down. Okay, and now you can see the pulsar again. I'm gonna change our dark black background. I'm gonna richen up the black background a little bit. There we go. That should do it. Try again.
Mark, these are actual colors,
Yes.
right? Not assigned.
That is correct. These are the actual colors that we're looking at. This is really what it looks like. Yep. So there is the Crab Nebula, guys. It's just beautiful. Mm-hmm.
Would we see
Wow.
those colors if we were standing in the middle of it? I mean, if we could survive that, of course.
Okay, let's assume that. So if we went to the middle of it, you might see a hazy view. Maybe a little hazy looking to you. But you wouldn't see anything like... You wouldn't see like this bright line here. And the reason is because when we're photographing it, we're letting photons strike our sensor over and over and over and over in order to build up an image. Well, our eyes don't do that. So your eyes, in fact, wouldn't be able to pick up virtually anything if you're inside looking out. You wouldn't see anything. You might see the brightest part of the nebula maybe with your eye, and that's only because it's really close, but it'd be pretty big in your sky. So you might see it as a haze, but you wouldn't really know what you were looking at, unless you really understood what just happened. Now, if you happen to be in a nearby star system, say one of these, like a star here, this star here might be within... It looks like it's within the supernova remnant, but it might be way to this side in front of us, and the supernova remnant could be way back out here somewhere, and this could be over here, right? Or that star could be way back here, and the supernova remnant here. Or maybe they are coincident in the same location, and that's overtaken that stellar location. But I don't believe so. It literally it's only been expanding since 1054 AD. All right, so it hasn't been expanding for very long. But it's expanded long enough that we can actually see that it's expanding, and there's video of the expansion actually taking place. You can actually see it over the course of the centuries
Oh, cool.
that we've observed it. Yeah, it's really cool. And the images just get better and better because, of course, we're using, telescopes like the Hubble Space Telescope to see it happen. That's really cool. Are you guys having a good time? I'm not waiting for you to answer because I know you. Hey, weird guy. Weird guy says it's too dark. Well, I can help you with that, weird guy. I can actually tell it to do a little processing and then work it back from there. Okay, so that to me is too light. All right, and let me add some color correction here. Get rid of a little bit of the green. That's better. And now you just see some modeling left over from noise. We've stacked 11. So let me come down here now and come back and give it a little darker sky. Too dark. Then we're gonna.
It's very dramatic. It's beautiful.
Yeah, it is very dramatic. Now we're going to affect this one and bring this down over a bit, because I want to actually take the center of the nebula and dim it out just enough so we can start to see the pulsar a little better. Now it's very obvious. And then we can come over here and come work back our black tone a little bit, bring it a little brighter, just a tad. There. And there's our beautiful pulsar. Yeah. And the other thing I like to do is sometimes I'll do this. So we just go full screen, okay, and we can actually see it and enjoy the full screen view. Move over. Yeah, go ahead.
Mark, can you tell us where the crab is? I mean, is the head of the crab on top where the red is, and where is? Because you kind of can't really see the crab. I've seen it before that you could really see arms, I thought.
The crab?
Mm-hmm.
I've never seen a crab.
No. I can't see one now. I
I
bet someone must have been playing with that image that I saw. I bet you it was manipulated.
Maybe so. Maybe so.
It's a long time ago.
Okay. Yeah, but this is just beautiful. If you notice, it's got such a beautiful set of features to it, you know. Really, really pretty features. And we're at 100% of the frame right now, and with 16 stacked, that's pretty good. So that's actually quite good. So what we'll do is, again, it's a beautiful image, and what I'll do now is we have no wind to worry about. Tonight's been wonderful for that, and the telescope's pointing almost straight up, so the fact that we're not getting any wind is very good news. So we'll come back out of this, and I'm going to just save this image.
Tara, it might be a little more crabby looking, so to speak, or if you think of a crab like a spider, it might look a little more spidery. If you saw it by eye through the eyepiece of a telescope, rather than an image like this, because the image is building up the faint areas of light where through the eyepiece you'd probably see those filaments more,
Right.
and not the space so much in between them. So that might look more like crab legs.
I'm sorry. Yeah, so it seems like we're looking down at the top of it versus a side view of it, is how I imagine it.
Actually, we're kind of looking at it at a sort of a 3/4 angle. Because there's also something else going on here. There's jets of material that have been identified in gamma rays and so forth that actually are coming out at angles to all this. So when you think of it as normalizing the axis to get the right axis, it's sort of laying kind of on its side and kind of leaning towards you or away from you a little bit from the initial explosion, which is kind of interesting. I'm going to just come in here and go back to our 1 second hyper shot so we can actually see where we are, where we're going. Come back in. All right, and then there we go. And now I think we should go check out something else. And that's the Crab Nebula over there that we just saw.
And now for
All right.
something completely different.
Dun, 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 dun. And now for something completely different. Monty Python's Flying Circus. I grew up watching that show. I have books upstairs that are all the scripts from Monty Python's Flying Circus.
Oh, that'd be funny reading.
It is funny reading, I can tell you right now, you know. I don't want that. What's that doing up? Okay. What's that doing? Go away. All right. There we go. All right, now we go on here. Good. Okay. So now, let me just bring this over here. All right. Okay. I think, because we can, I think we should, and then we'll work our way back. There's so many things to see here. Let's go check out the Rosette Nebula. I think it's beautiful. It's high enough to see, and so we're going to check it out. The Rosette is stunning in and of its own right, and if you haven't seen the Rosette before, be prepared to get your socks blown right off, because this is just a beautiful, beautiful stellar nursery. Okay, this is a stellar nursery that's almost, I think it equals the Orion Nebula. That's my feeling.
It's a rather different kind of object, isn't it?
Well, it's a stellar nursery, but it's not born of this in the same relative manner. Yet it's part of the same localized region, the Orion Molecular Cloud Complex. I believe it's probably part of the Orion Molecular Cloud Complex. And this is it. And this is just with our little hybrid view, you can actually see it. And I'm going to move it over a little.
I always thought of the Rosette as being a little more evolved than, say, the Great Nebula in Orion. I mean, that's a pretty good star cluster in the middle of the Rosette.
Yeah, but the Orion. Yeah, we don't need. It looks like a wreath. It looks like a wreath. Franklin Nebula. It definitely looks like a wreath, doesn't it? Okay, let's just zoom in to make sure our focus is good. I've got it on automatic pilot, basically for focus, but I do want to make sure that it is still good. Yep, it looks really good. All right, so let's zoom out of that. And Tara, when's the last time you joined us for a live stream?
It's been probably over a year, I think.
Don't ever do that again. Don't ever do that again.
The Rosette is not physically associated with Orion or the Orion cloud complex. Rosette Nebula is over 5,000 light years away, which say
yeah, and the Orion's 1,200.
Yeah.
1,500.
Yeah.
All right.
And it looks
fair enough.
Older to me.
I don't know about older. I mean, it's. When I get the first picture in here, you'll see what I'm talking about. So we go in there, 25 seconds, come off our hybrid shot, go into the stack, and in the live stack here, it says stacking pause. Why'd it go away? I don't know why it keeps killing the stack. All right, let's do this again. All right. This here is the old one. We're going to get rid of it. So we clear that. And then the next photo that comes in will be of the Rosette Nebula.
Well, they say there is a lot of star formation still going on inside.
Yeah.
They surveyed the nebula with the Chandra X-ray Observatory. That'd be interesting to see. I've never seen that.
Look at that.
There are a ton of other stars hidden inside it that we can't see optically.
Yeah. I'd love to...
2,000 stars.
Yeah.
So beautiful.
I'd love to see what this could actually do in about 1 million years. Because I imagine after about 1 million years, this glowing cluster will have dispersed, because the stars are all gravitationally involved with each other, and then they whip each other away and disperse over time. Just like our sun was born in a cluster, maybe not of this many stars, but fewer, and then our gravitational influence among those stars caused us to kind of whip away and leave the crib, so to speak. And in order to find the stars that we were made with, how about that? A sibling, a true sibling. We'd have to find a star that has the exact same chemical makeup of our sun. And we have. We've found at least one member of the stars in the cluster that we came from. We found one of them. It's actually in the southern hemisphere, or I'd show it to you, but I can't show it because it's down south and it's below our view, our field of view.
Aww.
Isn't this stunning, huh? Look at that. Let's do some color correction here.
Hey, Vera had a question. How big can people print the images that they're able to download?
Depends on how many we stack, but keep in mind that the size of the image is I can show you right here up in the size. It's like 4,000. The exact size of the image format. That's a good question. Capture format and area. The image size is, drumroll please, 4,144 by 2,822 pixels. So 4144 by 2822. That is the size of the image. So you can actually, that can make a pretty good size print. Especially considering that we have there's a lot of color depth. It's a 16-bit image. It's not a 32-bit image. It's a 16-bit image. Izabela knows what I'm talking about for sure. Maybe you do too, Vera. Isn't this beautiful? Wow.
Yeah, so over
That's
time,
7
the rose
stacked.
will just so the rose will just bloom and disappear and wither away.
In a sense. Let me show you what's going on here. Like, here's the cluster that was made in the center, right? In fact, it wasn't made in the center. Because it exists, the center was made. Okay, these stars are young and hot and have a copious hot stellar winds that push stuff away from them, like gas and dark nebula. Like if we zoom in a little bit, you can see the amazing dark nebula in this particular region, and it really is beautiful. Let's go right to 75%. All right, and on the right side you'll see this little snake of dark nebula, and there's another one here. But notice in here where the star cluster is, it's like it was hollowed out. All right, it was hollowed out. These young hot stars have made a cavity around themselves of relatively sparse gas and dust. All right, and that means that they formed in the middle of dust and gas and then began to blow away all the dust and gas. And what you're seeing is that process. You're seeing it kind of in the middle of blowing away a lot of this dust and gas. And so as we look at this, okay, we're actually seeing how, like over here, all right, here's the big cavernous maw of this spherical cavity made. But then over here on the left, all right, you'll see how the stars also affect the cloud around them, right? Because over here you start to see that the cloud is being sort of withered away in some areas over here. And that's because, as we look carefully, we can see that there's stalks sticking up here. And right there, for instance. And the star's high stellar winds, we say stellar winds, we're talking about plasma and so forth moving out at high speed from these young stars. It strikes an object and it starts to shear away all the dust and gas around it and push it away. But if the object is somewhat dense, then it can't do that. All right, it can't do that as well, I should say. In fact, let me zoom in on this to show you that, because I think that's really kind of a cool moment. All right, so let's zoom in, and I'll show you what I mean. So zooming in on this, way more than we probably should. See that stalk right there? That stalk is being literally attacked by these hot young stars. But this area up here is dense enough to prevent the stuff behind it from being evaporated away. So something's happening in here. Maybe another star is forming. But there's a dense field of something moving, being created in here. And this is the area where the radiation strikes first, and then it goes around the outside, and the stuff directly behind it and in line with those stars can't be evaporated, because this is like a wind block. It's blocking the wind. So what's behind it on the lee side of that is protected. And that's kind of how this works. Isn't that neat?
That's so cool.
Yeah.
Very neat.
Yep.
The scale of that is just incredible.
It is immense, isn't it? I mean, you look at this and you say, wow, you could get lost in there. What's down that path down here? What's down here? What's around the corner out and on the backside? It's amazing. You could spend lifetimes exploring the Rosette Nebula in real life,
Yeah, what he says,
but isn't this cool?
There are about 10,000 solar masses in the nebula and about 2,500 stars. And the big bright stars you see there, the big hot O stars, they're blowing the bubble in the nebula.
Yeah, and they're actually not long for this world. They only live a few million years. So we're looking at stars that are eventually going to go supernova. And they're probably going to go supernova before they actually leave the cluster. So that's going to mean that this gas is going to get added to by more supernova debris. And don't worry, it's far enough away that it won't hurt us.
And the article says that the plasma in that is much hotter than a typical H2 region. It's like you're talking on the order of 1,000,000 degrees Kelvin. Or 1,000,000 Kelvin.
1,000,000 Kelvin, yeah.
Excuse me.
Yeah.
So it's probably hotter than the Orion Nebula is.
Yeah. Do you know how many times I got yelled at? Go ahead.
No, go ahead.
I was gonna say, I got yelled at so many times because I said degrees Kelvin. Kelvin isn't a degree scale. It's just that is the scale. Kelvin. It's not degrees. It's Kelvin. And I finally got it through my head. This was many years ago, obviously. When I was getting the degree in astronomy, and my professors would say, it's not degrees Kelvin. It's Kelvin, man. It's like, okay, all right. If you put degrees Kelvin on a test, I'm gonna fail you. So I stopped using that. I realized. But once I understood the origin of the Kelvin scale and what it was used for, then I never made that mistake, because I realized, it's a scale that's meant to give us a 0 point. There's no -1 Kelvin, Although I have to admit there is research to indicate that maybe in some exotic cases that makes sense, but not to me.
Well, still,
Look
I
at
mean,
this.
the measured rate of change in the Kelvin scale is the same as the Celsius scale, is it not?
Yeah, it's just off by 273.15.
Yeah. what I always find striking about this image, I always comment on the star trains and stuff, but
Yes, you
especially
do.
up there at about 10 o'clock, there's that big, broad, curved bunch of
This one?
stars, and it looks like yes, that right there and a little higher up. That just seems to conform so well with all the rest of the rosette shape.
Well,
Right,
it's possible that
curving.
those.
Yeah.
Yeah, it's possible those stars formed as part of a shock front created by these hot stars. But I'm not sure. I'm sure the shock fronts made it out by this point, and they could have caused new formation, but I don't know for sure. I can't
Is
say for
north
sure because
up
I don't
and
know.
east to the left in this image?
Yes, north is up, and east is that way. No, that's
Which
west.
way?
I'm
Right.
sorry. Yeah, west. East is to the left. West is to the right.
Very good. The southeast quadrant there, they say is where the most star formation is actually happening. It may
Down
be
in
hidden
here?
behind that cloud. Yeah. Southeast quadrant.
Yeah.
May
Well,
be
that
hidden
could
in the
be.
cloud.
I mean, the James Webb Space Telescope could look in there and determine just how many there are,
I bet it will.
especially at all the many wavelengths it uses. But look at this gorgeous nebula, isn't it? Just beautiful.
Yeah.
It's incredible.
Excuse me a moment,
JSCO
please.
70s. Yeah. JSCO says Humpty, the red is due to hydrogen gas. Thank you. That's exactly right, JSCO. Remember, this is interstellar space is full of dust and full of gas. Dust, here you see some of it, and these black snaky lines that have been shaped by the very existence of these stars and other forces at play in this nebula. And then the fact that this is red is because of the ionization of hydrogen atoms, which were in here before the O stars sprang to life. But once they sprang to life, they had such powerful ultraviolet radiation. In fact, they give off most of their radiation in the ultraviolet, that they knock the electrons right off the hydrogen atom because they fill the electron with the energy of the O stars. The electrons bounce off the atom, hit other things out there, and jump back into the atom. And as they go back into the atom, they give off energy, and that energy is light energy, and that light is red, primarily. And that's called hydrogen alpha. It's a specific frequency, and this entire nebula is a reddish hue because of it. You having fun, Tara? You're on mute.
The silence was only because I was muted. I'm having a blast.
I'm glad.
This is always fun.
All right.
So, yeah.
We stacked 30, so we're going to stop this now.
So some of the stars that are here in this image, is part of that the veil of stars from our galaxy?
Well, this is within our galaxy,
It's
but it
still
could be
in
stars that
within
are
our
in the... It is, but they could be stars up here in the foreground, okay, and this is in the background. That's possible. So we could be looking through nearby stars to see this farther away. It is over 6,000 light years away. You know what I mean?
Yeah. Yeah, so
Okay.
obviously there's some being in between. So.
Yeah, for sure. All right, I saved this as the astronomical FITS file that I've mentioned before, and that FITS file can be viewed using a free FITS viewer. But if you don't
FITS
want to
viewer
take the
file.
time or you don't feel like it, then you can just I save it exactly as you see it right here in front of you, and that will be up on the server in a few minutes from now. See, JSCO said, Darrell asked Mark what he thinks about the new mysterious object they just found some 4,000 light years that is emitting enormous energy. Oh, the Gleam object. Oh, yeah. Yeah, the Gleam object is interesting. They think maybe that Gleam object is a special type of magnetar, which is a neutron star. When we look at the Crab Pulsar, we're looking at a neutron star. But a neutron star that has an extremely higher than regular magnetic field is called a magnetar. And it's possible that it's a magnetar causing the gleam object brightness. So that's a very strong possibility. But I can't speak to that. I'm not doing any of that research, so I can't tell you. But I do know that that's something that's very possible. After all, we do think... I'm clearing now because we did this one. And it'll be up on the server just like you see it. I do think that fast radio bursts could be caused by magnetars as well. There is a theory behind the way that those operate that could indicate a way a methodology by which they actually set off these fast radio bursts like they do. Remember, the fast radio bursts, or FRBs, are these millisecond bursts of extremely high energy. But just like a camera flash, they should have to reset. And sometimes we'll find an object that doesn't have to reset. It just goes bang, bang, bang. And there's really no way to know why it doesn't have to reset. And that's what the mystery is. We don't know what the mystery is with some of these objects. All right, so let's go now. This is our hybrid view of the nebula here. And let's go in, and I'm going to get our telescope awake again and ready for listening. And
what
now,
happened? Telescope
nothing.
hang
I
up
just
again?
no, not at all.
Oh. The
No.
Rosette is actually
I
quite
was
a
just
bit
finished with the
bigger
Rosette.
than the Orion Nebula, is it not?
It's definitely bigger considering the Orion
Angular
Nebula is so
size.
close. Well, angular size in the
mean,
sky.
Angular size.
Yeah, in angular size, the Rosette Nebula, I think it's angular size. I don't know what it is. I'm trying to see here. It says it's about a degree by a degree, 1 degree, 20 minutes by 1 degree. That could be true. But the Orion Nebula is actually just a little bit smaller than that. But being closer to us, if you put them next to each other at the right distances they are from each other, the Rosette would dwarf the Orion Nebula.
Well, that's what I was getting at. If the Rosette is over 5,000 light years away, is that what I said? And Orion Nebula,
Yeah, about 6,000.
That thing would dwarf Orion Nebula.
Yeah.
If it was same distance. That would be a
Oh, it would,
spectacular
yeah.
sight in the sky.
If we could actually detect it, it might look like about the brightness of Barnard's Loop to us. You know?
I bet something that big and bright that would have to show up.
Well, the stars would. For sure. Okay, we're going to check this out. This cluster. This is neat. And then we'll go down to some of these other objects and then head to the Horsehead in the Orion Nebula. And maybe we'll check out Thor's helmet. And maybe M47.
We still need to take another look at the 13th Pearl, too.
Yeah, I want to get down to Southern Orion and look at that as well as
I
look
wanna
at
see
the
that,
Witch's Head.
A dark hole in it.
Yeah. It's very tiny in this because of our, we're the wider angle shot here.
Yeah.
Here's Alzir, bringing Alzir in. And then off we go to this nebula, which you'll start to see. There it is. You can see it right there. It's amazing. See, look at, you see this nebula here. See this nebula there. Really pretty. All right, so what I'll do now is just bring those over a little bit more. Because you'll like what they come up with. See, when I do that, look at the star colors in the dashes. You can see all those different colors. Like this color right here is a beautiful greenish blue. I gotta check to see if that's a star or a planetary. Yeah. Wondering if there's a planetary nebula here. All right. Now we're gonna just go down a little bit here. Because what you're in for is a treat, because there's actually a lot of dark nebula in this view. Hey, Fantasy, how you doing? What's up, man? All right, so the telescope has to get a guide star. While it's doing that, we can set up our shot. It takes about 11 seconds for the telescope to get a guide star. All right, so let's go over here and go do a 25-second shot. All right, and we'll turn off our hyper mode because that messes with our shot when we take it. We combine them very rarely. All right, and we'll go into the live stack mode now. All right, and we'll see our live stack brings in this image. So here we go. Then we'll do some color correction if we have to, and then we'll actually enjoy the view. There we go. And we're at 40% zoom. I'm going to zoom out now. This is all reflection nebula, by the way.
That's intriguing.
Here we go. Yes. And it'll look a little better here in a second. Let it come in. And this object we're looking at is called IC2169. Okay. Also NGC 2247. All right. And this is a nebula that is around 1,631 light years away. All right. So NGC 2247 and IC means index catalog. It's another catalog that has different objects in it. And what it is reflection nebula and dark nebula. And just to let you see that's what it is. Here we go. All right. Here we are. All right. That's really pretty. Now what we're going to do is... This is a bright diffuse emission nebula over here. A bright diffuse Orion, like Orion type hydrogen alpha region. It's not Orion, but it's a similar type, and it's really pretty. All right, so let's get this.
So if it's hydrogen, why is it kind of yellow, or I mean greenish, bluish?
Oh, no. This red is hydrogen.
Oh, okay.
It's a large area of diffuse ionized hydrogen.
Okay. I was just thinking the stars, sorry.
Yeah, no, the stars are definitely scattered light reflection nebula. Look at this little snaky thing going all the way up to there. Isn't that cool? That's neat.
Very cool. It's alive.
And we see another one over there. Yeah. A lot of dark nebula in here. Yeah, well, I wanted to show you something you may not have seen. I don't think you did. I remember taking a picture, sending it to you of this.
It's almost like seafoam green with the red.
Oh yeah, right. Your eyes are gonna change the colors. You block out. If you block out the red light, then the green looks a little more blue, like it should. That's really pretty. Look at this beautiful dark nebula right here. Yeah. I'll just get rid of the name so you can see what's going on. In fact, I'll do better than that. Let's go into the full screen here. Her Majesty the Rosette. Thank you, Izabela. Every time you hit the like button, a new star is born in the universe. Yeah, and if you hit the dislike button, well, then a black hole forms over your house. Yeah, it's funny. I don't get a lot of dislikes, and I'm happy for that. You know, people know that I just want to see people enjoy astronomy and do public outreach. They know. Look how beautiful this is looking now. Isn't that something? Look at that. That's just really pretty. Yeah. Let's go exploring. Let's go to 50%. No, we'll go 75%. Because we've stacked 11 already.
Time flies.
All right. Yeah. Look at that.
So many stars next to those dark spots.
Yeah. That's really something. Yeah, and then we look down here. Wow.
It's like lights of a big city.
Right, as seen from space.
Mm-hmm.
And this is the river.
Yes.
This is the river.
Yes. And the mountains.
This is the island and then between the rivers.
Yeah.
City lights with fog.
Yes.
Yeah, right.
Light pollution.
It looks just like when I fly over, like, I don't know, Minneapolis, when I'm flying. Yeah, Vera says, you know, Mark, sometimes I can almost see in 3D. Yeah, your mind can help you do that, but it's not always accurate, Vera. But it is interesting. In some cases, you are seeing it correctly. And when you know you're seeing it correctly, it actually gets even better. You know, and so you can sometimes, like, imagine seeing it in 3D. But dark is not always farther away. Dark is sometimes closer to you. Like in the case of these dark clouds here, they're in front of the bright starry blanket behind here. They're in front of all this. And when you see that, you can actually, once you know that, you can actually see that in 3D. It's really a very, very effective mechanism for trying to see the night sky.
Yeah, because you think it's a hole you're looking through, you know.
Right, it's not a hole. It's actually an occluder.
The right side of
Go ahead,
that
Darrell.
image, I see like the spider legs thing again.
This here?
Is that
Yeah.
real or is that pareidolia?
I see that too.
This here?
Yes.
Yes.
And this?
And a lot of others.
Yeah, no, those are real. Those are there every time we take a photograph of this region. They're definitely real. You're probably looking at a closer version of some filamentary arms or filamentary legs of other dust, I think.
Yeah.
I'm guessing.
I see it all over the right part of the image.
Yeah. Lime seltzer.
Yeah. Going all different directions too.
Yeah. Well, see, now we've got 18 of these stacked, and you can see the image looks so much nicer. A lot more details showing up. This will make a beautiful image. And we can enhance the colors a little bit, too, just to give you an idea. Let's see where they are now. Oh, yeah. So now, if I were to take the colors and pump them up a little bit.
So now these are
Let's see how-
assigned colors then?
No, these are the actual colors.
Okay.
I'm
You're
just
not
giving them a
changing
little...
you're- Saturation.
I'm increasing the saturation, so when I get out of this now, you'll see the colors now saturated.
Oh,
Wow. Isn't that pretty?
Oh my gosh.
Yeah. Yeah. And sometimes the saturation increase helps you see some detail you couldn't see before. And sometimes it does the opposite. But I think that it's really just beautiful.
Some people really overdo it. That guy I sent you some pics the other night, I mean, his coloration was lurid. It was so overdone. Just really super hot pink and red.
Yeah, and I tend to err on the side of a little bit more reality. I don't go higher than what's needed to portray what it is, And I don't change the colors other to what they are. I don't go in false palettes, primarily because we aren't equipped to go to false palettes. What's that mean? It means taking this image, for instance, and showing it in the palette that the Hubble telescope uses. The Hubble Space Telescope palette is very particular, and it uses certain elements and assigns a certain color to them. So in that case, Tara's right. Those are assigned colors based on what the chemistry is. And you're not seeing it as it really is. But people put it in the Hubble palette because, the Hubble telescope did it, so let's do it and make it look like a Hubble image. You know what? That's not why they did it. They didn't do it to just be different. They did it because they're trying to showcase the differences between what sulfur is doing, what hydrogen alpha is doing, and what oxygen 3 is doing. The three main components to these narrow band images that they take. That's what they're doing.
I know. In Hubble,
we don't need to do that.
The hydrogen alpha, they painted a blue color, kind of a light blue, almost sky blue color.
Only so they can see certain features for researchers. That's all it's for. It's not to just make them look pretty to everybody, to make everyone think that hydrogen alpha is blue or green and not red. But just because they were showing them in a way that for science was better. And I wish that they would actually show, for instance, the pillars of creation in natural colors. I think there's a photo out there that they did. Natural colors of the pillars of creation. Because it's not done on the Hubble Space Telescope, it's done down here at the Space Telescope Science Institute, where they actually process these. Wow. So we've stacked 27. That's good. All right, so the first step is get ourselves out of this.
Have at it, Izabela.
She will.
Down on that.
I bet she will.
So beautiful. I mean, all throughout the whole image, it changes. It's just gorgeous.
Yeah. Okay, so now we're going to save this. So now we're saving the stack. You'll see the green bar. There it is. And then we're going to save it just like you see it here. If you want to just download a pretty picture, you can get it from our server. And Izabela has been so kind to be putting up these images, the image locations. Okay. Did you see the PNG file get saved? I did not. So I'm going to do it again. It'll just put 2 up there. I'd rather have more than I need than missing one. Now we should see the ping file. There we go. Okay. Alright. So that'll be up there very shortly, and you can go check it out, enjoy it, keep it for your very own. And you don't even have to pay for it. Isn't that great?
You can squeeze it and
I think
hold
science.
it and call it George.
I'm going to squeeze it and hold it and call it George.
Mm-hmm.
That was very funny. I remember that cartoon. It was Bugs Bunny, wasn't it, with the dog?
Yeah, Gossamer or something.
Gossamer. Oh, Gossamer. Yeah.
Big red
All right.
monster.
Yeah, that's right. All right. Very good. Okay, so now let's head over to the next location. After checking this out, let us go check out now. I promised it, and we'll do it. The Hubble's Variable Nebula. After we look at the in addition to the cone, we'll see these all in one shot, which I think is pretty cool. All right, so let's do that.
I'd like to see if we can see the Foxfur better.
Yeah. Tonight's a good night, so I think maybe we should be able to. Alright, let's, this is the cone right here, so we're going to go to this star. And that star, we'll head there. And away we go. And Hubble's Variable Nebula should be in the view. If not, I'll compose it so we see it. Alright, so we're making a high precision slew, SLEW, to a another star. Right there. Is that L0 again? It'll tell us down here. Right here. It's going to tell us it is L0. So we're centering L0 again. And then from L0 we're going to go off to the Cone Nebula. And if Hubble's Variable Nebula is going to be in the frame of view, you'll see it down to the lower right, I think. And if not, I'll make sure it's in there. Because when we take the picture, you're going to be astonished at what you see here. Okay, there's the Christmas tree cluster. There's the cone. And Hubble's Variable Nebula is just down here. I'm going to bring us up so you can see it. Alright, here we go. I remember the first time I saw the cone, I was just so blown away. It was so pretty. There's Hubble's Variable Nebula. Right down there. See that down there, guys? That little tiny nebula.
Oh,
this is the Christmas tree cluster. And the cone is kind of just barely visible there. This is a very faint cluster. It's got a lot of red stars in there, but they're not red because they're red. In real life, they're red because they're reddened by the fact that we're seeing them through dust. And they're a longer distance away. Alright, so that said, I can go up just a little higher here. Alright, I'm going to go up to the point where the Christmas tree cluster is right around the top here. And then that'll bring up Hubble's Variable Nebula into the view. How nice. This is great. Alright. Alright, so now once that stops, good. Now we need 11 seconds to capture our guide star. So because of that, I can set up our time. And this time we're going to go 30 seconds. We're going to go 5 more seconds than we have been. And we're going to cut this off down here and cut off our hyper view, and it'll go dark, but don't worry, we're just stacking. Alright, so here we go.
Did you add more time because it's dimmer?
I added more time because I wanted to show more detail. So yeah, I mean, a little more detail. It's only 5 seconds worth, but that can be amazing. This gray bar, this green bar you see there going across, that's the time. And so when it gets down to that, of course, we'll see our first image. So here we go. Let's check it out. Wow. That's really pretty. And look at Hubble's Variable Nebula down here. There's the cone right there. That's really something.
There's a lot going on in that space there.
Yeah, that's the cone, man, right there. Look at that. Let me get my cursor all the way. That's the cone, and you see it goes up there, and it actually has these 2 stars right at the very tip top, which are really cool. And this is the Christmas tree cluster that Darrell was talking about a little earlier. And down below here, okay, this is this right here. Okay, this guy right here is the Hubble's Variable Nebula, and we've actually watched that change brightness like crazy in the past. So I don't know what we'll see tonight. I mean, I can kind of see that it looks like it may actually have changed a little bit since last time. Look at this beautiful nebula. Look at how much dust there is in this region. It is spectacular. We've only stacked 3 of these. Yes, we can.
Okay.
The first one I want to do is
Might want to
I
let
just
it
want
build
to,
up some first.
yeah, that's what I'm doing. I'm just gonna let it build up a little bit. I'm actually gonna increase our black level and change the black level just a little bit. So make it a little bit better contrast between the background and our nebula. Here we go. Okay. So when I come in now. Hey Bobby Burgess, how you doing? Michael Klagas, the Virgo galaxy cluster in the sky. Not quite. It's actually deep in the east, hasn't risen yet. We're still in the winter sky. As we get into the spring sky, they'll be visible around 2, 3 in the morning right now. But in the next few weeks, we'll probably be able to see them at the tail end of a stream. Then, of course, in the spring, they'll be, well, where the Orion is now, in the southern horizon. Actually, we'll be able to view it very nicely. It's not southern horizon, but right overhead. Look at this beautiful nebula. I think it's better than, I said we got the best crab ever. I think we're going to have the best Christmas tree nebula ever, too. I'm going to go right to 100%, even though all we have is 6 of these stacked. There'll be a little bit of noise, but let's go see. Wow. That looks pretty good. Let's go over a little more. There's the cone. Ugh. Sorry, there's a delay in everything I do, so I gotta kind of ride the delay. There's a little bit of a guiding issue. It's not quite 100%. So I think what I want to do is fix that. So I'm going to get rid of this stack. I'm not going to save it. You'll say, wait, that's beautiful. Not good enough. I can do better. So there's a couple things you're going to do. First, we're going to go back to 1 second. And go back to the hyper mode. Alright. And then we're going to zoom in and make sure that our focus is good. It may have changed a little, and our focus probably needs to be adjusted ever so slightly. Then we can let the system take over again. Looks pretty good though, I have to admit. It might have just been a guiding problem. Yeah, I don't think I want to touch it. I think we're okay. All right, so, but you notice it has changed. If you remember what it was, you notice it changed. Okay, so what we're going to do now is I'm going to go into the telescope's computer here, and I'm going to tell it to change how the automatic guider is operating. So we're going to go in here and do that now. So you'll see, I'm noticing that our timing is a little bit delayed. There's always something. Okay. Okay, now we'll go grab the... So I just set the east-west guiding rate to be only 5%. And now this one here doesn't require that much change, but I have to set it to 1%. Believe it or not, that is usually enough. Alright. And now the guiding might show us a better imagery than the little extended blobs we saw. And then we'll be able to see things far better. Okay, so we come out of this, and now we're zoomed right now on this, but we're still looking at the same thing as before. So let's go now and do a bring this up to 30 seconds again. Actually, I'll do 30 seconds, yeah. And 30 seconds, and then do the stack. Do the stack, yo. Raymond Bobel, how are you? Okay, just a minute. Why does it do that? I don't know why my stack goes away. I must be hitting a key. Hang on, Ray. I'll be back to you in a second. Let's clear this so that the next image that's read out will be a brand new one. Let's see how it looks. That looks far better. There we go. Now the modeling you see is going to vanish after we start acquiring more imagery. Okay, you see how that modeling, it kind of looks rough? Well, watch down here when this new exposure comes in over here. Right? When this new exposure comes in over there, follow the green bar, you're going to see how all this modeling starts to go away little by little. So watch this very next exposure. Ready? Watch this. Boom. See that? It immediately started to go away. Did you see that, Tara?
Yes, it was very subtle.
It was subtle, but you saw it happen.
Mm-hmm.
And that's going to continue as we do more exposures.
We'll watch for the next one. Almost there.
Yeah.
And these are 30 seconds, right?
Yes.
Yeah. Here it comes. Here it comes.
Yeah. You'll see another subtle difference. Look at that. See, it did.
Yeah, there it goes.
I'll tell you why it's showing, Ray, because I didn't do this. Thank you for reminding me of that, Raymond. Now you don't see the desktop anymore.
Oh.
Huh? I was showing the left screen display. I was showing this. Okay? And I had failed to go into our proper display here. See, now I'm in the proper display. And this is better for us now. Here, let's do
I
this.
see.
Ready? Boom.
Alright,
I'll just bring this up now. I was in the wrong broadcast display, Tara.
Oh,
Yeah.
okay.
Well,
Oh, look, a
I had
satellite.
looked at the YouTube page.
Oh, yeah, look at that.
The satellite went through over here. Now, what that satellite, see, now that you might say, oh no, ruin the exposure. No, it didn't, because over time, as we start acquiring more data, this is not going to be there. That's a transient. It's only there for a short period of time. It's only there for that one picture. Then it goes away, right? So what's behind it is more of this noise and more of this space. And that's going to eventually dim this out to nothing, and it's going to be gone. It's going to disappear.
It
But
looks
look
like
up
a
here.
contrail of a rocket zooming towards that star.
Doesn't it?
Mhm.
Or toward me.
Yes. Hopefully not.
Not.
Well,
So check
you
this
don't want
out.
to be in its
Look
way.
at this beautiful dark dust cloud here in the Christmas tree cluster. Look at all this dark dust, right? Some of it's dust, some of it's mixed with emission, hydrogen emission. It really does look beautiful.
Can we scroll down
Yeah.
a little bit?
Yes, we can. I still want to get to the what you call it. Let's just get that out of there. Okay, let's get out of there.
Thank you, Raymond.
Thank you, Raymond.
What'd I miss? Oh, Raymond, thank you. Wow. This is beautiful, guys. This is really looking pretty. For those who don't know Raymond, he is a real superstar. He is an avid fan of SkyTour Livestream, and he's here as much as he can be. We admire him and we respect his presence. He's always offers up some really cool stuff and questions. He's just all around a good guy, and we enjoy having him. Look at this, Darrell. I mean, this is Hubble's Variable Nebula at our 100% zoom. That actually has some very different look to it. We actually have a lot of texture in here we have never seen before. I think that this is a really stellar night.
It looks like
Michael.
a comet.
Yeah, right? It does sort of look like a comet. In a way, it does have that appearance to it, doesn't it?
Yeah.
Oh, I'm
Going
just
down.
fantasy says, yeah, a comet, right? Hey, Raymond, you know you're the guy. You know. So I just want to thank you. You're okay. You always treat us well. We always like to treat you well too. You're one of the people like Izabela and other people, the rest that are here, that have always been there for us, and that doesn't go unheard and unresponded to, as you know. I sent you some things, Raymond. So, and I think you liked them. You said you did. So this is looking beautiful. Look at the modeling in here. This is a gorgeous photo. This is 12 stacked images. I really got to go back up and look at the cone now, because I'm wondering if the cone has really started to look better than we've seen it before. Let's go. Oh, I'm so excited. Uh-oh, here it comes. Oh, wow. Really, really pretty. You can see the separate stars up here. That's really pretty. You'll also notice there's another... These are basically stalks. And a hot young star is definitely evaporating with its high power stellar winds. And you can see that it's being hit right on the top, but there's a density in here that's not allowing the rest behind it to be evaporated just yet. It might be eventually, but this star here, it may be this star. I'm not sure, but it appears like it is. But it might be, it's one of the stars nearby here that's actually causing this evaporation to occur. And the biggest star isn't always the one.
Is the bright one S Monocerotis?
It might be S Monocerotis. This one here, I'm not sure.
I think it is.
Is that the one that's responsible here? I'm not sure.
I think so. I'd have to look it up.
That's all right.
Okay, now looking just to the upper left of the tip of the cone, that is the so-called Foxfur Nebula. And,
right here?
Yes. And
This here,
whatever
this whole
texture they talk about that reminds people of the fur of a fox, I don't see it. I just see nebulosity.
Maybe it's
I see this. I see this linear striations here. I think that might be what they're talking about.
I don't think so.
Do you see that?
I do see that.
Okay, well, let's try this. Let's try an enhancement technique where I'm going to turn on the unsharp mask, and let's see if that helps. Ready? Watch. Okay, how about now? Did that help at all?
No, I don't think so.
All right, let me increase
more focal length for that.
Focal length, maybe. I'm going to go to 1.8 and see. Yeah, that doesn't help me. I'll go back down to 1.25. Okay. All right. Alrighty. That's something else. This is just beautiful. again, guys, when you see these little green lines like this, you're actually watching the guiding process. And this is a pixel on the sensor that's an errant pixel. So it's a mistake, that just cameras all have dead pixels. And so we have that here too. And as the telescope's guiding, it's moving up. And you can see that it's sort of drifting to the upper side there. And that this little hook shows you the direction the telescope is drifting as it's guiding. It's keeping the stars perfectly aligned. Right? But the actual pixel is drifting while it's aligning this thing, aligning the objects. Looks beautiful. This is really nice. Let's go down, back out a little bit. Well, actually, before I do that, let's finish the journey and go up to the nebula, the Christmas tree cluster and nebula. Oh my. Look at that.
Ooh,
What do you think of that,
pretty.
Tara?
Looks
Huh?
like
Isn't
they
that
left their
beautiful?
Christmas tree lights on it still.
They did.
Beautiful.
Yeah. But look at this cloud, guys. Now, you talk about seeing things in 3D. How's that for 3D? You can
Oh, you
almost
really
see
see
this
that.
as a 3D, almost as a 3D cluster. Look at this hole in this material right here, a hole, and you see this blue reflection nebula here through it. You see that? It's like a little gap, and you're looking through it. Wow, I've never seen this before. We've never captured this before, Darrell. This is new to us. What a beautiful image. I can get rid of that halo too.
Gorgeous.
Wow. Yeah.
Sorry, I was away.
42. 42 is the answer. Yeah, you're right. That's right, Douglas Adams. The answer is 42.
Leave that right there for just a second, please.
Okay.
Stay.
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 Do you mind if I take it to 75% instead of 100?
Well, okay, I found a different picture of the fox fur now, and it is showing exactly what you are showing.
Okay, so you're saying this is
which
the
is-
Fox for Nebula.
Well, this picture is saying it's the fox fur nebula.
Okay. Well, it's sort of reddish, isn't it? It's a reddish fox. This is the
Yeah.
Red Fox Nebula.
Where do they get
David Schmidt.
fox fur?
Oh, it looks like fur, the baby when you brush a fox's coat. Maybe this is what's on the floor.
That's
Right?
it. I'm
This could be
sure
what's
that's
on the
it.
floor,
Yes.
right?
That must be it.
Mark, I'm going to send you a link,
All right.
and if you want to show it, fine.
Okay. David Schmidt, how are you? Good afternoon to you too. David Schmidt's in Thailand. That's why he's saying good afternoon.
Okay.
It's actually just after midnight here. Okay, I see that now. Well, that was shot at the Mount Lemmon Sky Center with the Schulman telescope, so I am pretty certain that that's the right thing.
Switch back and forth between the two. You can tell they're the same thing. The
They
figure
definitely
just
are.
to the lower right of the star.
Yep, I see it. I see it really easily.
I'm going to have
Very
to do
nice.
some more digging because that does not correspond with what I saw before. It's a really nice picture, though, and you're capturing it very
Yes,
well,
it is.
also.
Well, we actually we have 27 stacked. We'll go a little longer to further reduce noise, but there's a point at which you don't get any reduction of noise after that. There's a limit. There's a practical limit, in other words. But boy, it's pretty. It's coming out nice. Yeah.
Great picture.
I'll tell you one thing, and we're going to go back to auto right now, and then you see the whole thing, and then you'll be like, ah! All right, check this out when it comes back. Look at that. There is the cone. Now that's a beautiful image.
Wow.
Yeah, that's a beautiful image. And let me go back to one thing here. Let's go back. Let's do an image processing, an image process that it tells us what it thinks it should be. Oh, wow. Look at that. That's stunning. That's really pretty.
Just such a clear image.
It's beautiful. And this has all been after the maintenance visit to the telescope, where we could actually get the focus really fine-tuned. It's come out so much nicer. I want to go check out one more moment here. I just want to check out the Hubble's Variable Nebula one more time. And I'm going to come down to the bottom of the image. All right. I'm going to let that level out for a second. Then what I'm going to do is I'm going to do something else. I'm going to take this, and you see how bright it is in the center of that nebula. I'm going to tone it way the heck down. Okay. All right. So now when I tone it down, we can see some of the structure in here a little better. But one thing we have to do. What'd you say, Tara? I'm sorry.
No, they almost look transparent, like the wings of an insect or something. The structure.
Oh, I agree. I'm going to turn off the unsharp masking right now, this sharpening process. Let's see how that makes it look. Okay. This might actually...
This is one that would bear looking at again in a few days or a week.
Yeah, that's why I'm zooming in on it.
Yeah.
Okay. So, Izabela, when you do the chronology for this, make note of this special point at which we showed the Hubble's Variable Nebula, because we'll come back to it next time we see this and see what it looks like. You can see subtle differences. And then you see the universe changing right before your eyes.
Yeah, per what we were saying earlier about Hind's Variable Nebula, again, that was a bright star changing the appearance of the nebula over relatively short courses of time, I guess. And this is shadows being cast inside the nebula over a short period of time.
Okay. Bobby Burgess, I did not see your question. I'm sorry. Do you know his question, Darrell? I'd like to answer his question.
I must have missed it. Let me look.
Okay, thank you.
Well, I know he was wondering what images were captured tonight. You know, the list of the ones that we've seen.
Did he join us late?
He came
I think
a little bit later. Yes.
Ah, sorry, Bobby. Okay, if that's what you're asking, I will. I'll have to defer to Izabela because I think she's taking notes on what we saw tonight. Am I wrong, Izabela? If so, let me know. I don't mean to.
No, she's.
Okay, he wanted the names.
Yeah, the names of the nebulas that we saw, or the images we saw.
Well,
so
I know we looked
the
at the
Hind's
Pleiades.
variable. Mm-hmm.
Yeah, we looked at Pleiades, Hind's Variable Nebula, Crab Nebula, and
this one, the cone, the Christmas tree.
And the Christmas tree and cone, and Hubble's Variable Nebula, Rosette Nebula too.
Yes.
I'm trying to remember the order. Uh-oh. Hold on here. Did I miss somebody come by I didn't say hi to?
Judy just got here.
Where's Judy? Oh, Judy McClellan. Hi.
Mm-hmm.
Hi. I'm sorry, I didn't see you walk in. You just sneak in so quietly and take a seat. I mean, come on, announce yourself. Swing the doors open and say, "I'm here. Life may resume," and then we'll know you're here. Good to see you, Judy. Thanks for coming. This obviously is way processed down to show you this Hubble's Variable Nebula. But it's interesting because when I come in here and I reprocess this, you notice something immediately, and that is how much there is in the star fields that you just aren't aware of. Like, ready? This is what's there. Check it out. All right. Look at all this beauty that's waiting for you out there. It's just incredible. Just incredible. All right, we're up to 39 stacked images. We're going to go to 40, and then we're going to cut it there and move on. So we've got 5 seconds left in this frame. I'm so glad you could all join me, by the way. Pleiades, Hind's Variable Nebula. We also saw the Crab Nebula, the Rosette, Christmas Tree Nebula. Yeah, she's right. That's the order. All right, so we're going to pause now with 40 frames. That's more frames I've ever stacked in here than ever before. And now we're going to save that. And you'll see the green bar. The astronomical format is saved, and now we're going to save it as you see it. One of these nights I'm going to go through the FITS programs you can download for free to view things in FITS format. Right. They might be disappointing to you, though, so I think, isn't it, Raymond? But I think it's great to look at just these images, too, these pink files. Raymond, tell me the truth. Do you have all of our images on your desktop, on your PC? Come on. I gotta know the truth now. Gotta know. Alright. So that's all done. And so now we're going to get out of this guy. And I don't remember if I did that or not. I think I also saved the photo itself. But I'm going to do it again, because there'll be two, and I can always delete one. It's better than not having it. So I saved the stack, I know that. Okay. So the ping file is now saved. That's a regular graphics file you can just check out and enjoy. Okay, Ray, that's good to know. Alright, so now we're going to go down, say goodnight to the Christmas tree cluster, the Cone, and Hubble's Variable Nebula tonight. I'll tell you one thing, they really do look beautiful. They came out really pretty tonight. Best I've ever seen them. Really. I love seeing things for the first time in this telescope. I think what's happening is we were pushing to take photos of these while they were still farther in the east, all right, and not high up in the sky yet. But as you notice, look where the telescope's pointing. They're almost overhead, so they are probably the best images you'll see.
Cool.
Right? Yeah. Terry, you know that building so well.
I do.
You've had to go out
exactly
there and
what I'm looking at.
fix things that have gone wrong. You are just such an incredible workhorse when it comes to making this observatory work like smoothly, you know. You and Marianne.
Mm-hmm. Yeah, Marianne works very hard too.
Yes, she does.
Mm-hmm.
You know, Mark, I was looking
Yes, sir?
back at your server files
Yeah?
for Bobby Burgess's question, and
Yeah.
that does bring up something that I've always meant to ask you. None of them are labeled.
Yeah, they are.
No, they're not.
When you say they're not labeled, they're labeled with the date, and then in the later ones are all labeled with the objects by directory. Once you go into the directory, they're labeled. At a certain point, you drop in, and all of them are labeled. Thank you, Ray.
Let me go see again. I was there just a minute
Yeah.
ago.
I think you'll find that they're all
what
labeled.
Bobby was complaining about.
Aw, thanks, Raymond. For me and Marianne.
Thank you, Raymond.
Thank
That's
you.
just, yeah. Okay. I haven't taken a picture of the Casper, the Friendly Ghost Nebula, lately. Let's go do that. notice we're working our way down to the Orion Nebula and everything. The Orion Nebula is actually we're actually past the meridian right now with this, but that's okay. Let's go check it out. Watch the telescope. You'll see which way it's going to be angling. Fantasy says, the Orion Nebula is looking great tonight in my telescope here in California. Fantastic. That is awesome.
Okay.
You see how when you go...
I'm sorry. I'm looking at an older file now from 127. I see they are labeled. Tonight's are not yet labeled.
Oh, no, not at all, because I label them manually when I go in. So you're absolutely right. This is Bellatrix. This is the upper right-hand star in Orion. You have Betelgeuse and Bellatrix. No, that's okay. You're asking questions that other people might have too. That's fine. All right, and now the telescope's coming down, and we're hitting this area right here, this beautiful nebula. I'll tell you, if everything else is coming out good, this is probably going to look good too. Oh, I can't wait. This is going to be beautiful. All right. So let's go south a little bit. All right, make it go higher in the field. All right, there we go, a little more. Yeah. Okay. Now let's shift east a little bit. Yeah, I will specifically label them later. I do every directory. I label them myself directly. Okay, focus looks good. And so what I'll do now is we're going to do a 25-second photo here again of this region. This is called the Casper, the Friendly Ghost Nebula. And that's not my name. That's the name that Stellarium tends to use. I'm going to go into the live stack first. And I'm going to... Yeah. And then I'm going to clear this. And it'll automatically start going. Okay. So let's go back here. I was going to show you what the name was. Alright. So there's Casper, the Friendly Ghost, right here. Just a second. Okay. I think it's this right here. Yeah. That's Measure 78, also known as NGC 2068. Right. And now we'll our telescope is going to be pretty much centered on it. So we come back in here and you look at this. Look at that stunning ghostly image. It is beautiful. And now we have a 2-frame stack. Let's actually do a little bit of processing on it and change our black level just a little. Oh yeah. Drop the black level a little bit. Okay. Wow. Now
be back just a moment.
All right. Now look at this beautiful nebula structure here. This is a stunning nebula. Wow. I've just never seen it like this.
Wow.
We're going full screen. We're going full screen, baby.
Okay.
Oh yeah.
Go for it. Wow. Like a circular dust cloud going around it.
Isn't that something? That is just amazing. Wow.
The color's so beautiful.
Thank you guys for being here for this. This is just so cool to see. So cool to see. Thank you. Thanks for coming. Izabela says, I just love the Casper Nebula.
So is there an image of Casper the Friendly Ghost that we're supposed to see in this? Or is it just...
I don't know.
Okay.
I don't know. Would you mind if I make you hold down everything? Hold down the fort with everybody while I go and grab a drink a little bit? I just got to grab another seltzer.
Wow.
Darrell, are you
Okay.
back too?
No, he's not back.
Okay, all right.
It's also-
I'll be right back.
It's all good.
This is beautiful. All right,
It
hold on.
is. It is
Wow.
stunning. I'm looking at
I'll
at
return
the cat
momentarily.
stuff.
Holy.
Susie Cat says, "Wow, stunning and gorgeous, cool and cold." Yeah, I bet that is freezing out there. Looks like there's some red up though to the upper left. Look at all that red that's kind of inching its way into the picture. Where on the right, it's really blue. Beautiful. It's getting more resolved too. Beautiful. Hey, Darrell. Mark will be right back.
We're good.
Yeah.
Sorry about that. I had to take a pill.
Ah, good. You're so good and regimented. It's good. Boy, that's gorgeous. Darrell, do you know if there's supposed to be an image of Casper the Friendly Ghost in this that we're supposed to see?
I have no idea.
Neither did Mark. We're just asking.
As Mark said a little while ago, Stellarium seems to have some pretty fanciful names for some objects. I've heard of M78. I've seen M78. I just never heard it called Casper the Friendly Ghost before. It's pretty, whatever it is.
Sure is. Gorgeous. There's like two different stars. I mean, it's obviously both of the stars, correct, that we're looking at, and the red nebula below.
Yeah.
Mm-hmm. Yeah.
I would have to imagine Casper's something to do with that brighter part up in the upper.
Wow. Look at this. Holy cow. Thank you, Tara. Thank you.
Fantasy says that if you look in the telescope, you'll see it as a little ghost-looking nebula.
Mm-hmm. Cool.
Well, I can imagine that.
Fantasy also,
Look at that
said, "I
beautiful
wondered
nebula."
what that smudge was." Well, there you go. Here's the smudge.
Who said that?
Fantasy.
Oh, I wonder what the smudge was. Okay. Okay, there you go. Yeah, the blue part, as Weird Guy says, the blue part kind of makes Casper's domed skull, if you want to look at it that way.
Yeah. Well, I would think the center blue part, or the lower blue part, is more like the head shape.
Yeah. This is our full frame view, by the way, so...
You know.
I could maybe see that.
Wow. This is really pretty. This is... I mean... And seeing the rest of this dark nebula in here, this is really wispy stuff in here. Look at the detail in here. This is beautiful. We're capturing it very, very well tonight.
Those dust
And we
things
can
are
see
really
it.
dense.
Yeah, and we're seeing a little bit more of the this brown. This is actually going to get better and better as we go. In fact, let me go into the stack and start playing with things that I shouldn't play with. Okay, let's try, first of all, let's do a stack process. Right, get through this and see if this shows us any better what we're looking at. I mean, you can really see the extent of the dust now. That looks really cool. This kind of rough edge look is just a temporary feature. It has to do with the internet data transfer speeds. That's going to go away. In areas that have less data, like the dark of space, you'll see a weird looking modeling, but that changes. Where it's high density data like this in here, look at it's already beautiful, and it'll continue. It'll trickle through the rest of the image for a few seconds. Look at that! Wow. That is just beautiful. I wonder if we can push that even a little bit more. Let's see. This way, maybe? Wow. All right, let's just try that. See what that does. Let that trickle through. See what we get. Wow. This is 19 images stacked already. This is beautiful. We'll stop at 20 because there's a few more things I want to look at. Wow.
Might be interesting to see this within the context of the larger molecular cloud. Good little context on it.
Yeah.
It's really silhouetting that dark nebula, no?
Yeah. Really nice. This is beautiful. Okay, we're going to pause. I'll wait for this last image to come in, make it 21 shots. Stacked. Oh, thank you, Raymond. I'll make sure we push this well. Judy McClellan says, Casper head stick out of the wall. Yeah, I can see that.
Why didn't I think of
Fantasy says, almost what you see in a telescope with the naked eye, but minus the arms and face. That's kind of cool, Fantasy. Thanks. All right, so we'll pause it now, and we'll save with 22 frames stacked. And you'll see the blue, the green bar across the top saying we've done so. And then save exactly as seen. Okay, and with that, we now know that this is going up to our server. Yay! So we'll clear this out. Casper the Friendly Ghost. Good night, Casper the Friendly Ghost. All right, and then we're going to come back and drop into our 1 second photo and put on our hyper mode so we can actually see like a finder, a vision enhanced finder, a night vision finder. Okay, there we go. And now let's go and check out and we've all been waiting for it, so let's go do it.
Wait for it. Wait for it.
Wait for it. I know. I wonder if I should do the witch's head first, Darrell.
Sure.
Because that's on its way down. It's past the meridian.
Yeah. Yeah, give it a go.
Remember we also did the cosmic bat, but it was wasn't as good, but that's all right.
See if you can catch a little more of the lower part of the nebula, which is the upper part of the witch's head. For like that picture I sent you the other day.
Yeah.
You kind of
let's see
the hat.
Why don't we go here then, and then work our way up?
All right.
It's either going to go to Cursa.
Mosaic sometime.
Go ahead. Yeah. All right, well, here we go. We're going to go to the Witch's Head, which is to the right of Rigel. It's a nebula that's a reflection nebula, and it is a nebula that is actually being illuminated by Rigel. Rigel is responsible. So we're probably going to go to Cursa, and then drop down to it. And I've noticed that the coordinates of the Witch's Head are not entirely accurate. So it may go to the wrong place. I might have to steer it to it, which is why I'm saying that. Black cherry seltzer. Yeah, Cursa. When it goes to Cursa, it doesn't seem to find things the way I want to. I don't, it's heading in the right direction anyway. Okay, let's see where it is. All right. Well, it might have actually gotten there. Because I see that star. That star right at the very top of the field is actually this star at the top of the field. And I can see a vague remnant of this outline. So we should go north of that then, if we're gonna, because right now I don't think we can see the entire thing. And we got something else right there. We got two objects right there. Are those little galaxies, or what are those? No, we can't fit the whole thing.
Look,
even with a field rotator, we
Those are smudges.
They do look like. There's smudges. No, Judy, there's no wind tonight. Yes, great observation, and I'm telling you, I was worried about that. Let's go check this out just a little bit. Yep, there's two galaxies. Check them out. There's actually another one too, right down below. Okay. Well, that's Crisi-Aljaza. That's the star at the north end of our field, but I want to take us up maybe to here. What do you think? We'll leave off the chin, Darrell, and just maybe look at this middle part. Like right here, maybe? Well, let's go eastward. Go ahead.
The whole upper part of the head, which is the lower part of what we see,
Yeah.
I mean, the face is the most interesting part of the witch. And
Right here.
it's so darn long, the whole nebula. Yeah.
Yeah.
The whole nebula is like 5 degrees long or more. It's huge.
Yeah, it is.
And if you're looking at a 1.5 degree cross section, you know, you'd need more than 3 frames to catch it all.
Oh, yeah.
There's a whole lot going on outside the bottom edge of the frame, which is where you would say, what's her hat?
Yeah.
I don't think it's quite as interesting as the face is.
Well, we're centered on the face right now, so why don't we take a picture of that and see what we get?
Sure.
All right. That'd be kind of fun.
I
Okay,
hope
so-
she's ready for her close-up.
Mr. DeMille.
Mm-hmm.
So, yeah, I know it doesn't look like there's much here, but that belies what we actually have going on. So we're going to do a 30-second photo here. And we'll turn off our processing. Let's go check out this star here and see where that is in our frame. It should be in there. Okay, so there's the live stack. Live stack's underway. Let it go. And let's go now look. So that's the star, Crisi-Aljaza, which I told you about. It's on the right side of our frame. This is what it looks like in the planetarium view. This here, when it comes back, is what it will look like. Here it comes. There we go. So here you can see that. Is that the nose, Darrell?
Yes, that's her nose. And you
Okay.
can see the upper lip above the nose, then the mouth is open, then the lower lip toward the top.
Mouth is open here.
She's
This is
upside
the
down.
lower lip.
Yeah, she's
Yes.
upside down.
Okay,
Yeah.
I see
Your
it now.
your pointer's right next to the upper lip, Mark.
Yep.
Then
Yeah,
the
I see
opening of
that.
the mouth.
Upper lip?
Yeah.
No,
That's
this
the
is the
upper
upper
lip?
lip, I thought. This is the
No.
upper lip here, right? This is
No.
the upper lip?
Yeah. Yes.
That's the upper lip.
Yes.
And then the gap above the upper lip is her mouth open.
Mm-hmm.
And then
This
the
right here?
next protrusion sticking left
Yes.
is her lower lip.
That's the lower.
Yes.
That's the lower lip, and then the chin is out
Correct.
of shot.
Correct.
Chin is out
Okay,
of shot.
I see it. I
That's her
got
nose left to center.
Yeah, that's right here.
Mm-hmm.
This be one ugly witch, let me tell yous.
And that's the mole.
Okay, well
right
we've
to the
stacked. To the mole. Okay, we've stacked. Let's do a process here. We're gonna also do a. There we go, and I'm gonna also affect color. Let's do a color balance. See if it changes much. Yeah, like that helps dramatically, actually. And now let's see about a slight shifting of the dark value. Let's see if that hurts or helps. Wow. Probably a little too much.
Doesn't really hurt that bad.
Yeah, but it didn't really help. Izabela, what a witch. She sees different faces, Darrell. See, guys, to Darrell, okay, you gotta understand, the universe is one giant Rorschach test. You know, splotches and what they look like, right? I mean, I look at these and you know what? Some of these things I can't even see. And Darrell says, no, just look, that's obviously the nose. Obviously, that's Bill Murray eating a baby Ruth. What? I remember.
I mean, that's pretty obvious.
To this
right
day, I
there.
can't see that. See that?
Well, it's
Pretty
obvious.
obvious.
Once you know it's
especially
upside down.
Yeah, if you could get the whole chin in, it would help. But I always thought it bore a remarkable resemblance to the Wicked Witch in Wizard of Oz.
Mm-hmm. Melting! I'm melting! Oh, what a world! What a world! What a world! Where's my baby Ruth? See where the telescope's pointing, guys? Okay, so it's actually pointing more toward the west right now. Okay, because that's about as far west as we're going to look tonight, that way. And then, because we could look farther, but this is about the interesting thing that we're looking at here. So, okay, we've got 7 stacked. Very nice. This reminds me of Joe Satriani, this music, which you guys can't hear because I didn't include that in your sound background. Well, there's Marianne. And she says, Mark, Darrell, and is that the awesome Tara?
If that's the awesome Marianne, then yes. Hi, Marianne. How you doing?
Hi,
Yeah.
Marianne.
Marianne's really the awesome one.
Marianne is the one that stood by us to make this observatory a reality. Without her input, it wouldn't be here. And without Tara's input, a lot of the work wouldn't have got done. I'm just the guy that wanted to show pretty pictures.
Thank goodness.
You know? Yeah. And without Darrell, we wouldn't have all this wonderful, colorful commentary that we get each time we go streaming.
All this information. My
Yeah.
God.
But hey, you know, Darrell gets this really nice, expensive observatory to play with, you know. You know. Because he knows that whatever he says, you know, I'll probably want to do anyway. So it's like, hey, go check this out. Okay. You know.
Well, sometimes. I know a few months ago, you were wanting things to look at, so I started looking up things for you.
Mm-hmm.
All that.
Yeah, and
up
the
in
dark nebula.
Yeah, the Cepheus and stuff. After you got the telescope collimated.
Yeah. Once I got the telescope all fixed, I was unstoppable. Well, I don't know that I'm stoppable yet. I don't think I'm stoppable
not.
yet.
You're not.
No, I can't. I'm just very happy that there's a lot of people like all of you out there that are very interested in this with us. Ronald, I never said hi to you. I'm sorry. Yes, Marianne speaks the truth. Vera said hi to you, Marianne, too. That's nice. Okay, I'm going to stop this at 13 and move ourselves back because we want to look at the southern Orion region before we go to the Rhine Nebula or the Horsehead. All right, so we're at 13 now. 13 actually was a lucky number for me. The house I lived in before this was 13 Oak Street. And this house is 1313 Mockingbird Lane. No, it's not.
Do you walk a crooked 13 mile and how does that go? There's something like this.
I don't.
13,
I walk.
13 Mockingbird Lane. That the
Remember that?
monsters?
Yes.
Yeah, that's right.
Fred Gwynn. Big chin. I love that. That was really funny. Of course, after seeing him in My Cousin Vinny there with Joe Pesci, Utes? Utes? Yeah, the Utes. Joe Pesci pretending to be a lawyer. Yeah, a Ute. Yeah. Okay, so that's saved. We can clear this now and get out and go into our next item here. I did not include it here and stick the name of it because I had actually not had intended to spend that much time on it because it was past the meridian by enough that I didn't want to, but I did it anyway, so my apologies. Okay, so now let's go and take ourselves to gross. That's nasty.
You see the face there?
Actually, it's easier to see it here.
Yes, and when he moved it, she was flying backwards, upside down.
It was Sister Bertrill, the flying nun. Oh.
Oh, yeah.
Remember that?
I forgot her name, but yes.
Yes. Yeah, with Reverend Mother. That's the theme song, remember?
No, I don't remember.
I'm kind of
Sally
a
Field?
savant.
I believe, yes,
Sally Field.
Young Sally Field.
And to fly, she'd push her head down on her little winged, sister of the whatever convent she was in. That, Our Lady of the Eternal Flyers. I have no idea. And they, what's that?
I'm sorry, go ahead.
No, that's okay. You like what?
I liked Sally Fields and Smokey and the Bandit.
Oh, yeah, well, she was good there with Burt Reynolds.
Mm-hmm.
All right. We're going to the 13th pearl now, Darrell.
All right.
No, Marianne, I'm not mocking the Jersey language. I would not mock the Jersey language. Okay, we're going to Saiph, the lower left star in Orion. And then we're going to go from there. We're going to jump up to a little nebula that's down below the Orion Nebula. It often goes unnoticed, and in any kind of photographs, it goes overexposed and you miss it. So we're going to try and take some exposures of it to actually show the nebula. Then we're going to vastly overexpose it to show you what's in the Orion region. Right there you see the Orion Nebula at the bottom of it. And right here in the middle, right about there, should be, this is the 13th pearl. It's a tiny little nebula that has a very, very dense black dust bar across the nebula. And if I take an exposure that's too long, it's going to wipe it out, so we don't want to. Let's just do a, we'll do 6 seconds on this and hope that's not too much. And we'll stack that. So, here we go. And let's...
Ooh.
Oh, it's not there yet. I have
Star
to
at the
process
top's
this.
pretty.
Yeah. Let's do this processing here. Okay. There, this is perfect. All right. Now we can look at that and let that come in for a while and zoom in on it a little bit. And you'll see that little T-bar. There it is. Look at that. Well, either I or expose the T, or I try to bring it out. Bring down the brightness. Even 6 seconds was too bright. There we go. That's a little better.
Bobby,
So you
we
see
are
now
at what's
that-
called the 13th pearl.
Yeah. Also known as the Rubber Stamp Nebula. For whatever reason. Let's go to 100% here. So check it out. There it is, Darrell.
Yeah, that's another one I think we need focal length to see that
Sure.
hole.
It kind of looks like a ball or a pearl there.
Well,
Maybe.
it's,
Yeah, and
if I remember right, it's a star inside a small nebula, and there is what looks like a dark cloud over the right side of the nebula. And they say nowadays that that's not a dark cloud; it's an actual hole that we're looking clean
Ooh.
through the nebula in. But we need more
Interesting.
magnification to see it, and we probably need more focal length to do that.
yeah.
Cool.
Yeah.
It looks intriguing, though.
It does.
I always get confused.
All right.
Is it a hole or is it dark, dust or something? And that looks like dust, but now that's a hole. Interesting.
Well,
They used to
so
think it was dust.
Yeah. That's interesting.
yeah. All right, we're gonna clear this stack now. And you know what?
I assume
Yeah, I'll
that's
clear it
Orion
because-
Nebula just out of frame to the top.
It is. We just saw it before. What I'm gonna do now is get rid of this, and I want to just take us up to the Orion Nebula now. Actually, no, I don't yet. I wanted to stay right here and do a 30-second exposure. Actually, 35-second exposure. All right, because I want to show you this whole region and what we have in it. There's a lot of stuff going on here that you just don't see unless you do a longer exposure. All right, and by a lot of stuff, I mean dust. So much dust, you cannot believe it. You cannot believe it, Tara. You cannot believe. Okay.
Here it comes.
Yep. Take a looky. Alright, so what we're going to do, the first couple aren't going to look all that good, but you're also going to notice that there's never a photo we take anymore where it doesn't have satellites in it. So we'll just keep going here.
Oh, I see it.
They're in the bottom center.
Yeah.
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 Throwing me there for a second.
It's another
It is red.
smudge.
It is rather dim.
Yeah. We'll lose it in a short period of time here. So this is the southern Orion region. And I won't leave that up there the whole time. It's just, and let's go back in the stack. Let's do a couple things. Now that we have two of them stacked, let's do a color correction. Okay, there we go. And let's do a processing on the nebula here to check out more of the data. Okay, we gotta let it come in and stabilize. then we can kick it up a notch. A lot of gas clouds, a lot of dust clouds that show up here. And I'm going to kick us over and brighten this up a little bit. All right. What did Sally Field do that was naughty?
I can't say.
Well, then why'd you type it?
Well, somebody else was exclaiming about Sally Field.
Oh, okay.
Jessica S. said, everyone liked Sally. Cute.
Well, that's true. Everybody did like Sally Field.
Oh, yeah. Donald Kunzer said, Darrell, what red-blooded man wouldn't?
The blue blood kind.
Bobby Burgess, I'm reading back up a little bit. Witch's Nebula. It's called the Witch Head Nebula. The Witch Head Nebula. Jessica, the car Bert and Sally were driving was a 77 Trans Am. Black and gold.
With gold trim.
Yep. My twin brother had a 1976 Trans Am. That was the car selected by the senior class. His senior year out at the Air Force Academy. All the seniors got Trans Ams, and he got one too. That was a nice car.
Cool.
Wow.
Those were the cars to have.
Yeah.
They were at the time.
The old muscle car.
What was sad about those, when he had that 76 Trans Am, I had a 1968 Pontiac GTO. And both cars had the 400 cubic inch engine in it and a 4-speed transmission. And my car had twice the horsepower his did, because by that time in the mid-70s, due to emission regulations and gas shortages and all that stuff, they had seriously detuned the engines in all the cars. His had, what was it, 180 horsepower, and mine had 350 or 370, I forget. I could run circles around him I could outrun him in a straight line. His car handled circles around mine. Very nice handling car. I love that GTO.
It didn't have as much power.
His car, no, it had half the horsepower that mine did.
Wow. See these clouds, these beautiful clouds that are down here below the Orion Nebula? It's just gorgeous. And we've stacked 9 so far. We'll go to 10, because I know you want to see some of the other good stuff. And besides, it's 1 in the morning, right? So, I know some of the people watching have already fallen asleep at the computers. They're snoring and drooling on the keyboard. I get it. All right, so there's 10 shots here.
Don't talk about me like that.
I resemble that remark. Okay, save the FITS file. There's the green title across the page. And then when this comes down, save exactly as seen for those who want pretty pictures. The next one says the PNG file is up there. Okay, so we can now clear this and move on. And where are we going to move to? Where she stops, nobody knows. Round and round she goes. Where she stops, nobody knows.
You going to start where you left off?
And start where I left off?
Yeah, you're going to move up to the main part of the nebula.
Yes.
Yeah.
So now we're going to just move up. All right. And this is kind of a cool thing, because this brings us right smack dab into the Orion Nebula. Brightest nebula.
Here it comes.
Yeah, that's the brightest nebula in the sky. And right above it is another beautiful object. Yeah. That right there is the astronomer's dream land right here. It's the Orion Nebula and the Running Man Nebula. And I think when I talked about the Running Man, I was mistakenly calling it NGC 1999, right? Is it 1977?
I don't remember. I remember reading about 1999 just the other day. I don't remember what it is anymore either.
I think that's the 13th Pearl.
I think you may be
Well,
right.
let's
Probably
go
one
down
that's
and check
stuck
it
in my
out.
head.
Yeah, it's 1999, and the Running Man Nebula. I can't stand when my screen gets like this.
Looks like it went out of focus.
It's not. It's funny, right? Because it's not obviously out of focus. Running Man Nebula, NGC 1975.
There you go.
All right. Okay, so that's the Running Man and the Orion Nebula, and there they are. So what I'll do now is I'm going to bring them just a little bit to the west side here. We're going to shift a little bit to the west. All right.
Yeah, it does. It looks pixelated to me.
Yeah, it does, because we're just waiting for it to settle down. Again, between here and there, the internet load is just whatever it is, you know. But that won't happen with StarNet. Go ahead.
Well, I have a question for you. Do you have to let the telescope rest at all when it moves from one spot to another? I mean, does that help with the resolution?
No, well, the reason I'm letting it sit right now is because of the fact that we need for it to get a guide star, lock onto the guide star, and begin guiding. That process takes 11 seconds. So during that 11-second time, I come up and I do the stuff here up on the right. I actually change the parameters and get us ready to go. So I'm not wasting any time. And now I come out, and as soon as I click this button down here, okay, the green bar starts going, and I can now bring up the stack.
You know, vibration damping is a thing with telescopes, Tara.
Yeah.
Yeah, I was wondering.
I mean, if you just stop dead, then the telescope does move a little bit, but this telescope is on a fixed rigid pier, of course, as you know. Ah, look at that.
Ooh.
Yeah. When this stabilizes, yeah, this is gonna be just stunning. Wow. And the thing is, you're not gonna see a pixelated view, by the way, when you see the images in the server. They're perfect. Okay, this is what you're seeing here. Any pixelation is simply the result of the internet speed between here and there, but the pictures are going to be stunning. Now you can see this is in 3D without a doubt. This right here is overlaying the bright nebula behind it. We've overexposed this, yes, because I'm showing you all this dust in here. Look at this pillowy, billowy dust. It looks like somebody took the guts of a pillow and just laid it right out all over the ground here. You know?
Oh, it's beautiful.
So that's what I think is pretty cool.
It
right.
does have a
Now,
fluffy look to it.
Doesn't it, though? And the satellites act like they're piercing the heart. They're just going through it all over the place. Anyway,
It's just the thread
just-
sewing the pillow together.
there you go.
Mm-hmm.
Okay, let's take this and maybe increase the amount of data we're seeing. All right, let's increase the data. Okay, now we'll let that come in, and you're going to see some real pretty stuff. Fantasy, yes, says, wow, yeah. It looks fake in a sense. Don't give away my secrets, man. It does, doesn't it?
Well, there's just such a variety of color in that shot.
Exactly. We're seeing a bunch of different processes out there in the interstellar medium. We're seeing dark nebulae that are just reflecting light of the bright stars for real. We're seeing dark nebulae that are scattering the light of the bright stars, causing them to look blue. We're seeing hydrogen emission, which is that beautiful red color we talked about. And we're seeing hydrogen emission from within a blue nebula, causing them to look magenta. When the light colors add together, red plus the blue will be like a magenta color in light terms. So it's not like paint. But still, it's kind of interesting, isn't it? And now over here on the left, you can see this cloud developing here. You see this beautiful long cloud here that's getting filamentary knots in it as it comes and it overlays the nebula here. It's just beautiful.
What's the green?
Oxygen.
Ah, yeah, the green is oxygen. Yeah, very good. Thank you, Darrell. Doubly ionized oxygen. Again, in the core of this nebula are 4 stars called the trapezium. And those 4 stars, all very hot young stars, have very strong stellar winds, and they emit a lot of radiation in the ultraviolet spectrum. That ultraviolet radiation ionizes the hydrogen within several light years of them, and ionizes the oxygen within several light years. Now you'll say, what's oxygen doing in space? What's hydrogen doing in space? Well, when the universe was made, it was mostly hydrogen gas. Hydrogen is a very simple gas. It has a proton and an electron. Boom, done. Oxygen is more complicated. All right, it has multiple protons, multiple electrons, but it's made in the hearts of stars. And when the stars explode and go supernova, it scatters that oxygen all the way out to the interstellar medium, where someday it and the dark dust that's also created from these supernova explosions could combine, commingle, and serve to form a stellar nursery to make more stars. And so this oxygen here is oxygen that's doubly ionized by the trapezium stars. And it's just a gorgeous location. I mean, this photo is just like a painting to me.
Tara,
and I'll get rid of that halo.
Earlier tonight, during the radio show, I guess, Mark showed M33, Pinwheel Galaxy and Triangulum.
Yes.
And he zoomed in on it, and what he pointed out as supernova remnants were all that same oxygen green color.
Yes, okay.
Some of them were huge.
It's so pretty.
And I pointed to a bunch of the red areas too in there, and those are basically that galaxy's Orion nebulas and other larger lagoon nebulas and nebulas like we see in the Eta Carina Nebula. I mean, all these very large red hydrogen emission regions. This is looking really pretty.
You and I have talked about this before. That supposedly when you look at the Orion Nebula in a telescope, what you see is gray. I've always thought I could see some green, and I mentioned before that in one telescope I thought I saw wisps of red. In my mind's eye, though, when I look back at views I've had of Orion through the eyepiece in a telescope, what I see is always green. Very green, the whole thing.
Well, that stands to reason because your eyes see green best of any of all the colors. And the color receptors in the eye, and most of you guys know this, the color receptors are the cones and the black and white receptors are the rods. Well, we have cones clustered around the center of our retina and rods around the outside. So, for instance, when you look through an eyepiece or you look at something in the sky and you're not sure what you're looking at, if you look to one side, the rods are now picking up a lot of that information, and it might look brighter to you, and it might actually show you what it is. That's called averted vision. Averted vision. AVERTED. And averted vision is something we learn in astronomy early on and spend our time avoiding. We want to have a big light bucket so we can just look directly at our stuff like this. Okay?
Yeah.
So here I zoomed in on the Running Man, NGC 1977, did I say? And this is the Orion Nebula, Measure 42. And what's in between is this beautiful... Huh? 1975, thank you, yeah. Yeah, right. You're right, NGC 1975. And then down here is this beautiful dark nebula in between. And you'll notice it looks brown. It doesn't look blue. That's because it's far enough away so that its light is just picking up the light of a bunch of other stars and not scattering a lot of high-frequency light. So we're seeing it as a beautiful brownish color. And that's kind of what its real color is. Effectively, it's soot. It's soot created by stars when they explode. But we know also that it is very hard. It's a silica particle that has ice on its surface, methane, formaldehyde, methanol, and a bunch of other ices, including water and carbon dioxide ice. And those form a thin layer on top of these particles because that's what happens in deep space, in the icy cold of these regions. And in this case, if you look here at King Kong in between, okay, right here, this is King Kong. I'm just kidding, I just saw that in the chat. You'll notice that this material here is really dense in some places, and you can't really see through it. And an infrared telescope could see inside of it and figure out what's going on. But we can't. Uh-oh. I just yawned. I'm sorry. That's what happens.
Uh-oh, me too.
I know.
Yeah.
Oh, boy. This will be the second to the last object. There's always one more, right? Okay.
Fair enough.
So this is 21 stacked. So let's go back now and let's go to the full screen view, the full Monty, as they say. There it is. That's really beautiful.
Oh,
and
it's
now
so
let's see if our processing can pull out some more data. It's probably going to go more subtle, yeah. I prefer just a little bit more data.
You know what you
Yeah.
need?
An astrograph?
I'm
A
sorry.
Raza? You said you know what you need, and I said an astrograph, a Raza?
Oh, you dropped out for a second.
Oh.
Well, a lot of times I say you need more focal length. You need an even wider field sometimes too.
That's true. That's true. That's
No,
right.
you need something that rotates the lenses to wide field, this field, and the really super zoom too.
Well,
That would be cool.
I was actually trying to figure out a way to actually rotate the camera so that the long axis could go up and down if I wanted it to. It only needs to go 90 degrees up or down, but we have cables to worry about. But I've actually figured out in my head a way to actually make a little gearbox that won't interfere, and I could rotate that camera and then rotate it back, and then it'll hold it in position. The only trouble is, like I said, it's going to take some time to install and test, and I have to worry about cables.
It'd probably be easier
So.
just to put rotating tube rings on the telescope.
Except this telescope doesn't have that capability because it's a fork mount.
Oh, well, duh, yeah.
But otherwise, I would. Because I do have rotating tube rings for a tube assembly, but it's actually for the 5-inch refractor behind me that's mounted on the other telescope for SkyTour East. Like I said, with the price of wood and everything, I've not built the observatory out here. I'm still waiting on that. But
Or
this
if you
is
have
beautiful.
a nice refractor, they build the rotators right into the focusers now too.
It's a great idea.
You're talking
This
big
music
bucks.
is very nice. This music is very nice for this nebula.
James
Which maybe you
Dugan,
can't
why?
hear.
Why is the large Magellanic Cloud not labeled? I didn't know that. Of course, I don't look in the southern sky.
Well, we're still looking at a possibility of a telescope below the equator here. That will happen if I get support from a foundation. We don't have any of that right now, but we'll see.
Well, Marianne and I volunteer to go help get it built.
But you be careful what you wish for. You might be doing a lot of the work.
Marianne will be Crocodile Dundee down there and never come back.
That's all right.
That's
Nothing wrong with that.
Right. Knife? That ain't a knife. This is a knife. Yeah, that's what she'd say. You know?
She'd say taser. That's
Okay.
not a taser. This is a taser.
Right, this is a taser. Ah! Okay, that was a good capture. Now we're gonna go and do one more that I think everybody seems to like, and it's actually in a good position. This might be one of the better captures that is coming up here.
Rosette?
It's gonna be beautiful. Yeah. Barnard. I was gonna say Barnard 33.
Yeah.
Which of course is the horsehead. All right.
And if
so,
you had a wider field for that, you could capture the entire belt of Orion at one time.
yeah,
with,
but now you're talking about just getting a wide angle telephoto and putting it on a tracking mount.
Yeah.
You know, or literally mounting an astronomical camera to a regular telephoto lens and
Something
putting
like
it
that.
piggyback on a telescope. Yeah. Oh, none of that is beyond the realm of possibility, I can tell you. All right, let's go. We got our 1 second delay here. I'm going to get rid of that and re-engage it.
Right tool for the
All right.
job.
Yep, and then come down here. And now, let's go into Blur City here and go over. This is Alnatak. It is the leftmost star in the belt of Orion. Then we have Alnilam and Mintaka. And if we come down, let's go to we'll go to this IC right here, which is gonna bring us to what we want. All right. Now you're gonna see these two beautiful nebulae that we enjoy very much. It looks like it's taking us to Saif again as a stopover point, and then back up to the Alnatak region. They might say, why didn't I just select Alnatak and just zip around there? I could have, but I noticed some weird database issues. So I'm just going by what I know tends to work, I think. So now, shoot up there. Ready? Here we go. Ready for liftoff. There we go. And then you see these objects just sort of pulling into view here. That's really pretty. It almost
Like a
centers on
sudden
your
star.
favorite star. Right?
Hmm.
Yeah, it almost... Oh, look at this little satellite zipping right through here. Watch. There it is. That would make a big diagonal. That's probably
that's cool.
That could be Starlink.
It's like a bug.
Right? Very good. Very good, Tara. That is a
I've never heard
bug.
that.
Hey there, Dean Bustador. How are you? It's only 10:30 in California. It's 1:30 here, pal. This is our one more. Yeah. So let's check it out. Okay, this looks like a good position to start from. And now we'll go and do a 25-second shot. Alright. And now after that, go into our live stack. Our green progress bar over there is running now over here. Our stack is active. And we're going to see this beautiful image come through. The three Marys, Donald. I didn't hear about that either.
Donald, I just looked that up. The three stars of the belt are known in Portugal, South America, and the Philippines as Las Tres Marias in Spanish.
The three Marys. The three Marias.
As Tres Marias in Portuguese.
Así es las Tres Marías. Yo entiendo ahora.
That's true.
Wow,
That makes
that's
me think
good.
of something else.
What's that?
Oh, you remember old, what was his face? The astronomer guy late at night on public TV?
Oh, Jack Horkheimer.
Jack Horkheimer, yeah. I saw him one night. He talked about the stars in the belt of Orion. And he said
Alnitak and Mintaka.
Yeah, he said Alnitak and Alnilam were about the same distance away. He said Mintaka was twice as far away. But I just looked it up as part of this Three Marys thing, and Wikipedia, whatever that's worth, says Alnilam is 1,260 light years away. Alnilam is about 2,000 light years away. And Mintaka is 1,200 light years away. So the middle one is farther away.
Yeah, I think when Jack Horkheimer was mentioning that, he was going from what we knew at the time. So he was just looking at the current data, you know.
Yeah.
I'm guessing.
Look at the glow of that flame.
I know. Yep.
Alnilam is 375,000 times more luminous than the sun.
Alnitak is also a very hot O star.
Yeah.
Very young.
It's the brightest star of Class O in the night sky. Alnitak is.
Yeah, and we're looking right at it. And Alnitak is like another star that's going to go supernova. Unrelentingly supernova. It's going to really tear asunder this entire molecular cloud region once it explodes. But it'll take time for that to move out. Yes, Dean. Jack was on PBS. And his show was like 6 minutes long or something. It was just like the last few minutes before the end of other shows. It wasn't like a half-hour show. It was like a 6 minute or 8 minute show, if I recall.
Yeah.
What was it called? Is it Here's Looking Up, or?
I think so. Something like that. I
Yeah.
really enjoyed him.
Yeah.
Yeah, the public TV stations here at least played him like right before they ended programming for the night. Remember back in the old
Yeah.
days when stations shut down at night?
Yeah. And you just saw the little test pattern. It's like everybody went home.
Color bars.
Yeah.
Well, the first
Yep.
the national anthem had to play.
Yes.
Oh yes.
Mm-hmm.
Yep.
Reminds me
Some
of a
stations they just some stations just played static. It's like, oh well, this channel's off the air.
Right, that's right.
Yeah.
You'd
'Cause
have
they were
to
just
get up
over
and
the
go
air.
change it.
Over the air
test
channels,
pattern.
yeah.
Test
Yeah.
pattern always had an Indian chief's head in it.
Yeah. And sometimes there were just the color bars, yeah. And sometimes when you saw them, you would just hear, ooh, the high pitched whine because it was saying, yeah, we're off.
I still hear that.
That's hilarious.
John
That's
Prine.
because you have tinnitus.
John Prine, on his very first album, he did a song called the Torch Singers Song. And one of the lines from the song was, "Makes me feel like the Sunday funnies after everything's gone off the air." He said it with a lot of twang.
hmm Daisy and Zoe Amethyst say the flame is our favorite. I'm glad you like that. I'm glad you like the flame.
It's really changing.
Flame's an interesting nebula here, because these tendrils of dark nebula are actually blocking the bright nebula behind them. So what makes it look like the flame is actually the accidental overlay of a bright, relatively uniform nebula by this dark nebula here. So it looks like a flame, but without it, we just see the regular nebula. But it's because it's being overlaid by these fingers of dark tendrils, it looks like this. And of course, they're interspersed. It's not in 2 dimensions; it's all in 3 dimensions. So there's an intertangled mess of dark nebulae. Some of these are going down, some of these are coming up, and it's all every which way. But
got
really
quite a
cool. Notice,
Quite
Go
a
ahead.
satellite trail there too. Is that
yeah,
tumbling
but
or
it's
are
going
the
away.
brakes,
Yes. No, there's no delay between the photographs. So you see bright, dark. That's because it's slowly tumbling. So this is a satellite. It's probably not a satellite at all, but a rocket body, which could explain why it's moving so slowly. But you'll notice it's getting dimmer. That's because with each successive exposure, the actual data behind it is overtaking it, because it only existed on one frame. And then the new frames come in and overlay parts of it. That happens especially where you see like dark nebulae. It takes a little longer for it to go away. If it's a bright nebula, it goes away almost immediately because it's overlaid right away. Now, I particularly like this region because there's some areas in here that are just so much fun to examine. And let me see if I can show them to you.
Star Hustler, that was it. Thank you, JSCO.
Oh, Jack, yeah, thank you, JSCO, yeah. Jack Horkheimer, Star Hustler. This right here, you can see this stalk in here. That's a stalk inside this blue reflection nebula, but this star is actually evaporating. In all likelihood, it's evaporating part of this area, and the denser parts are remaining behind, and the stuff behind it is shielded from the stellar wind. So it may not be going away. That could be very much what it is. Yep. And of course, then we have the Rosette Nebula, which now just disappeared because I'm trying not to scroll too far, but
It always looks to me like like a seahorse head nebula.
oh yeah, you know why? Because of the curled face, that little.
Yeah.
Because seahorses have that little curl to their snouts. Yep, but you're right. That's exactly what it looks like.
Yeah. Always reminded me of the knight on a chessboard.
Yeah,
Oh, interesting. I see that.
the Black Knight. Well, my chess pieces were black and white, so the Black Knight is what I used to see it as. Is this not beautiful? Look at all the red hydrogen that's in here. It's just beautiful. I can't wait to see the fettered image that's not subject to data transfer rates, which makes it look worse than it is. There's some beautiful nebulous detail in here. And then over here we have more. Look at these little fine lines of dark nebula in here. I've never seen those before. It's really beautiful. Oh. Looking at a beautiful night sky is like going to church for me. You know, I've never felt more at ease than when I'm looking at the night sky.
Well, that's cool. Awesome.
So beautiful.
It is.
It's just very relaxing to stare up at space and to just contemplate your existence and dream. I find it very fun.
Yeah. Like on tonight's radio show, guys, we talked about where were the atoms that make you up before they were in you. They were in a dark cloud, much like this one. And then they made their way to the Earth. And then we talked about, they made their way, I should say, to a solar nebula, which then became the sun and the planets. And then those atoms ended up becoming part of all the animals on the planet long before they ever found you. So you could literally have atoms within you that were in a Tyrannosaurus Rex, or you could have atoms within you that were Pteranodon, okay, or a pterodactyl, which is what Tara probably had as a pterodactyl. That was her
right.
joke from the radio show. That was hers, not mine. And
It
so
only took me a couple of seconds to get that.
Well, but the funny thing is, okay, we also talked about where the precious metals like gold, platinum, and silver come from, and those come from merging neutron stars. Remember we talked about that earlier, and we talked about how the fact that every human being has gold in their blood. It's a trace amount, but if you could take it out and make a cube out of it, it'd be a cube that was 0.2 millimeters square. And Ronald, who is ERRT here, he immediately perked up as a gold miner and said, "Wow, I can start killing people and taking their gold." Well, not really, because it's only 0.22 cubic millimeters, and that's not a whole lot. But we also have other trace elements in our bodies. But the gold came from merging neutron stars. And I also said, too, that the fact is, if any of you have ever had upset stomachs and you take Pepto-Bismol, well, the operative compound inside of Pepto-Bismol contains bismuth. Bismuth is an element in our periodic table, and all the bismuth comes from colliding neutron stars. So whenever your stomach has been upset, just think, when you take a teaspoonful of that stuff, that chalky taste is the bismuth, and it's the bismuth that came from colliding neutron stars. You're literally drinking a piece of collision products from merging neutron stars and colliding neutron stars. That's cool, right? And don't you think?
Oh, I have a question about that. Is the bismuth,
Go for it.
Did the bismuth do the same thing like the heavy metals did? Did they form veins and we mined this bismuth?
I think
That's
bismuth.
generally how they get stuff, is mining it.
But I mean, did it go
Darrell
molten
used to work in a
and
mine.
separate? So it went molten and separated as well.
Yes, the differentiation process. Differentiation worked the same way. The bismuth went and was spread to the interstellar medium in atoms, and then it was made into the solar nebula, or merged with the solar nebula, and the solar nebula made into material on the planets. Obviously, the bismuth has a low melting point, so it stayed molten for quite some time. But the bismuth ended up being, I would imagine bismuth ended up being part of other compounds and is extracted from those compounds.
Yes.
But
Okay.
When I worked in a mine, since you mentioned it, I worked in a molybdenum mine, which is a refractory metal It's used in alloying steel and in lubricants and making other compounds and stuff. It's very slick to the touch, kind of a greasy blue-black color. But it wasn't just molybdenum in the ore. There was all sorts of stuff. And we occasionally even, well, I never saw it, but there was occasionally even gold in there. And the mine was a huge operation. 3,000 people worked there. And they said, well, we're not in the gold business. If miners, being the way miners are, if they ran across a gold vein, they'd start following the gold instead of the molybdenum, which would screw up the engineers' plans, because they had been laying out these tunnels and drifts and, drill hole locations and all sorts of stuff for months and months. They'd bring in a management crew, and they would wall off the gold vein and seal it behind concrete, because we're not in the gold business, we're in the molybdenum business. But there was a rumor that up above ground in the big mill building where they processed the ore into molybdenum, that there was a room back in the back that had a gold table in it, had a flotation table, and that gold was what they were harvesting. It was management only. Management wore orange hard hats, and it was management only. But I saw with my own eyes where miners would hit gold veins, and a management crew would come down and build it all up with concrete forms, and they'd pour concrete and seal it behind the concrete so they couldn't get at it. But on the other hand, though, the miners, being the way miners are, they often, everybody carried big lunch boxes up there, and it was called high grading. And miners would find really nice rock samples or ore samples, whatever, and put them in their lunch boxes and carry them out of the mine. And that would get you fired if you got caught, but they all did it, and you'd see some pretty amazing ore samples and crystals and various kinds of expensive minerals showing up in rock shops all over Colorado that came out of the Climax mine.
Oh, that's funny. It's kind of like the Post-its of an office, is the minerals of a mine.
Wow.
I saw something interesting. I'm sorry, go ahead.
Go ahead. No, I was just going to say, we finished with the Horsehead here. That'll be up there really soon. And maybe we can get to just one more object here. But go ahead, Darrell. You said you're going to say something.
Oh, well, you were talking about gold. If Ronald's still here. Ronald,
Don't get him too excited.
Watch the show Gold Rush on Discovery Channel? I enjoy watching that. There was some episodes a while back where they were right up in my old stomping grounds up in Leadville, Colorado. Recently, though, they, I think it was just one of the last week's episodes, they talked about when they're gold mining in Australia, they have learned to check the leaves of eucalyptus trees, that the eucalyptus trees actually take up gold from the soil and it winds up in the leaves of the trees. And rather than do a lot of destructive drilling or mining looking for gold, well, nowadays they go out and pull leaves off the trees, and if the trees have gold in the leaves, that's where they start digging for the mines.
Oh, I thought you were going to say they start squeezing koalas.
Oh, no.
Or the compressing trees to squeeze the gold out of them.
Yeah, they compress the koalas, you know. It's like, wee!
That's not
Aww, no.
I like koalas. Okay.
Koalas are cool.
They are. But boy, they can be mean. I know they don't look like they can, but they can be meanies. All right. It's actually too late. Okay. All right. I'm afraid this is it. We are. Oh wait, what's that?
No.
What's
Just
that?
one more.
Oh, the Seagull Nebula. Oh, the Seagull Nebula. Okay, the Seagull Nebula. Yeah.
Jonathan
Okay.
Livingston.
Jonathan Livingston, Seagull Nebula.
Seagull
I hate you.
Nebula. Uh-huh.
Why did you have to be there? Oh,
It's a
it's
short
gonna be
read.
so nice too. It's just past the. We're gonna get Sirius probably as our star, as our guide to the. Oh, that's a Sirius star if I ever saw it. Very bright. Look at that. Wow. The halos are due to the telescope system. Oh, look at that. I don't have time for this. I have to do this, but I can't do it, but I gotta do it.
Yeah, I
Christy
should've
P,
looked.
thanks, man. I didn't see you. I didn't even see you got here. Sorry, man. Thank you for coming out, Christy. Really good to have you here. Thank you.
Mhm.
I should have left a half hour ago.
Yeah, you stay. If I'm staying, you're staying.
And if you're staying, I'm staying. Wait. Yeah.
Wait, what?
Huh?
Okay. Now we're gonna bring this down.
Last one, Darrell.
This is the last one.
Makes me feel
This last
like
one.
the Sunday funnies. After everything's gone off the air. Everything's gone off the air.
See that, folks? You know he's tired when he starts singing. When he
I
starts
usually need
singing,
to have some
it's
alcohol in me to sing John Prine.
Now it's just Earl Grey.
well, what do you need in you to?
Me too.
Oh, I'm still drinking my black cherry seltzer.
Seltzer.
Okay,
Seltzer.
12 seconds here.
2 o'clock in the morning.
Yeah,
It's almost
black
midnight
cherry
here.
seltzer. Yeah. Jesus. Okay. We'll do 25 seconds. I should have my guide star by now. Let's go. Off you go. Into the stack.
To the yonder.
Dang. Oh yeah. Oh yeah. And you'll see me tonight with an
Kool-Aid
illegal
Nebula?
smile. Right. That's right, Ronald. He's tired. He's singing. Oh
That
my.
was a long time ago, Donald. That album came out, just about 50 years ago. It's hard to believe.
Wow.
John Prine's first album.
Okay.
He was singing in a bar in a basement in Chicago, Illinois, and he got discovered by Chris Christopherson, of all people.
Wow.
Helped make him a star.
That's awesome.
Oh, John Prine died of COVID last year. That's too bad.
I don't even know the
Is that-
name, actually.
Is that the head of the seagull on the right?
Yes, it is.
Smiling,
This is the seagull.
toothless and smiling.
No, actually, there's a. Its head is turned. This is the seam in the beak. Last I checked, and his head's turned. Either that or he collided with a Toyota. I'm not sure.
Or a window, the wings flat.
Yeah, he hit a Prius window.
Mm.
Thanks, Louis Ta. It is a beautiful nebula. And as the data comes in, it's going to be even more stunning.
It almost looks like a rainbow going through that.
Oh, I see what you're saying, because the color changes across this way.
Right. Yes, exactly.
Yeah. Yeah, it's really pretty. Darrell's definitely tired.
Yeah.
Well, the Seagull's the last one, though. I think. Although,
Therefore you
might
am?
be some galaxies. Might be some galaxies now.
Maybe yes, maybe no.
Yeah, maybe. Yeah. Daisy and Zoe still here. Excellent. Let's see what's going on here.
What's the name of that song, Darrell?
Pretty good.
Pretty good.
What's pretty good?
Name of the song.
Oh, okay.
The chorus was pretty good, not bad. I can't complain. But actually, everything is just about the same. Also on the first
All right,
album.
Fantasy. Take care. Thanks for coming. We're gonna close up here pretty soon ourselves.
I think I'm scaring everybody away.
Well,
Nice,
I don't even know
Fantasy.
who this. All right. Thanks, man. Good to see you. Tara says, "Gun Fantasy."
Mm. Mm. I'm getting tired. It's hard to spell ud and ait.
Yeah.
It's my shorthand.
Yes, which you're really good at.
I am good at shorthand, actually.
Uh-oh. Come back. Okay. All right. All right, after this one, we'll call it at 10 frames. All right. So we'll pause it here. Save this. This will be nice. And now we will save it exactly as seen. Alrighty. Alrighty, and that's it. We are done for the evening. I want to thank you guys for coming on out to SkyTour live stream. I enjoyed your company tremendously, as did Tara, I believe, and Darrell.
Absolutely.
I can't speak for them personally, but I do believe that they have enjoyed your company as well.
That's a nice picture.
It is nice.
It's a very nice picture of the Seagull Nebula. Yeah.
And it's
what
almost
we'll do
midnight,
next-
and I'm about to turn into a pumpkin.
Don't lose your glass
Oh.
slipper when you run to bed, okay?
Yeah,
And don't fall down. Don't fall down. You'll become squash.
yeah. Okay. You all take care and have a good night. Thanks for
Good
coming.
night, Darrell.
Thanks for having me, Mark. Great having you
Thank
on,
you,
Tara.
guys.
Thank you. It was so fun. Thank you both so much. And thanks, everyone. You're all so fun.
All right, guys. Well, we'll see you guys. You guys have a good night, and we will talk to you really soon. So long.
Good night. Good night, good night, good night.
Take care, everyone. Good night.
Bye-bye.
Adios.